right. Welcome, everybody, to Standing for Truth. My name is Donny, and this is Matt. And we are coming to you tonight to address the heat problem. Matt, did you briefly want to cover what exactly is the heat problem, and why do critics, skeptics of young earth creation in general, why do they believe that this is the supposed death of creation science, as the title of Gutsick Gibbon and her video is the heat problem, the death of scientific creationism, Matt? So can you tell us briefly what exactly is the heat problem, brother?
Sure, absolutely. Thanks for sharing screen, by the way. The heat problem is a single problem that exists in a global flood model for young earth creation called catastrophic plate tectonics. And in this model proposed by John Baumgartner, who is right here, who created this model, not the guy with the arrow. Sorry, didn't recognize that photo that
I think you might have just circled Russell Humphreys. John Baumgartner's to the far left.
Oh, okay. Here we go.
There he is. Yeah,
I highlighted the wrong person over here too.
But that's Dr. Humphreys. He does some great work as well.
Yes. So he proposed that in the beginning, God created the Earth, and he proposed that an order of 4.5 billion years worth of nuclear decay at the present rates unfolded rapidly in the Earth before the end of day 3, and about 600 million years accelerated nuclear decay happened during Noah's flood. The only problem with that is 5 times the heat generated that would melt the surface of the Earth. So he proposed that God must have gotten rid of the heat somehow. So he proposed a miracle. So the critics say, ha, we got him. They just left the scientific explanation for something. Since they don't believe in God, that's all that they wanted to hear, because they don't have faith. They don't care what the Bible says. So any model that would go against their belief, which is deep time evolution, they instantly hate, they attack, and they consider it anti-science. And this would be an example of something that is anti-science, because it's not testable, predictable, anything like this, right? So he proposed that God removed it. How would we prove that? So today we're going to be talking about this heat that would be generated, and how we don't need to go into why his perception of why these radioisotopes needed to be sped up to begin with. So we're going to drive into that. Also, I wrote an entire book on this subject. You can find it on Amazon. It's just called Radioactive Decay, a new scientific perspective on the young age of the Earth. And here's the different chapters for anybody that's interested, because we cover ice cores, the ice age, spreading of the seafloor, the heat problem, the Oklo reactor, which people probably would be interested in learning. So what I'm going to do is I'm going to give it to anybody at all who joins as a member for Standing for Truth channel, or anybody that wants to become a patron. Doesn't really matter if it's $1. It doesn't matter even if you are one. What we'll do is I'll just send him the link for the Google Documents, and what you can do is save it as a PDF, and you can go through all of the stuff that we're going to systematically go through today to answer any of these questions. Now, remember, this is a single problem that has to do with catastrophic plate tectonics. This is the flood model that you don't even have to hold to. You don't even have to believe in this. So when they say all of young earth creation is refuted because of the heat problem, what they mean to say is a single global flood model that Answers in Genesis believes is refuted by them invoking God using a miracle to remove the heat during the flood. So just remember, they're just blowing it out of proportion and saying every other flood model was basically ignored because young earth creation can be refuted with this single argument. And it's just not true. It's just a single flood model. Anyway.
Now, if I could jump in and ask a question based on that. Do all flood models, regardless of which one you hold to, whether it's CPT, HPT, a flood model besides those two. You know, we kind of have a hybrid model in many ways. Are they going to have heat budget and radiation issues regardless of the model?
Some do, some do not. Some have a little bit of a heat generation because they still form mountains. So you still get subduction heat from friction. Others propose that the friction wasn't there, like hydroplate. However, the hydroplate theory, which was by John or Walt Brown, proposes that all of the radioactive elements formed during the flood. That's, again, massive amounts of heat, but a totally different problem. So yes, their other models do have other problems. And these are competing models, so they don't come together and try to solve each other's issues. They're really kind of competing.
So Creationist Crybaby, one of our biggest fans here, appreciate it. He's asking us about heat problems due to the formation of limestone and catastrophic plate tectonics. So Matt, as you said, catastrophic plate tectonics would suggest the rapid movement of the plates, continental sprint, rather than plates moving extremely slowly. They're moving at meters per second through the floodwater. So that would obviously create a lot of heat and friction. And then the rapid formation of limestone. And I know we would argue that a lot of it is chemical, in the sense that when the fountains of the great deep broke open, they provided the necessary factors to rapidly produce a lot of the limestone that we see today. But regardless of your flood model, is there going to be a heat issue when it comes to the formation of limestone, and then the movement? I guess the movement of the plates is going to depend on how much you believe the plates moved in general, right?
It also comes down to what you believe the ancient seafloor bed was made of. Because if we look into that very study, we actually find that the next form of generated heat would actually come from this subduction and convection. And what happens is, the faster it moves, the more heat that's generated. Plus, as he mentioned, the creation of limestone. Creation of limestone, being a chemical process, would generate a bunch of heat. But as we see from vents at the bottom of the ocean today, it's still producing limestone as of now. So we can still see limestone being formed, and it doesn't need accelerated nuclear decay, and it doesn't need massive speed to produce it. It just needs a proper chemical reaction, and the heat can have been in subterranean water, as where it would come up and now heat the oceans up. So yes, we'll cover that. Matter of fact, there is a specific video I have on my channel. I don't know where it is on yours. Sorry, couldn't find it in time, but I took a screenshot of this one. You can find it on the playlist on radiometric dating over on the Young Earth Creation channel, where I found a mathematician who was able to run a program based on this concept. So that's what we need, right? We need to be able to show the math. We need to see how much heat was generated, what happened to it. If we have massive continental sprint with the mid-Atlantic ridge pumping lava out at a fast rate, that's a lot of heat. How are you going to solve that? But as you guys know, today we're talking about the accelerated energy, which is off the charts too much. And that is where the main focus, I think, today is going to fall, because accelerated nuclear decay literally melts the earth. You have problems with the subduction, for sure, way too much heat. And you also have another one. Matter of fact, let me find it. I'll show you guys real quick. The three problems. The first one is accelerated nuclear decay, as you saw.
Right. And that's the biggest one.
Yes, off the charts high. Then the next one is catastrophic plate tectonics, the fast continental sprint and subduction. And the third, bombardment from space. Remember, catastrophic plate tectonics poses that every single meteor impact that we see in every layer on Earth occurred in 1 year during the flood. That's a lot of heat coming from space hitting the Earth. So they have three forms of heat that is actually taking place.
I'm feeling hot already, brother, just thinking about it. I'm starting to sweat.
Exactly.
All that heat.
Yeah. Matter of fact, we can read directly from it. From the widespread occurrence of plutonium halos in biotite flakes in granite. This implies that there was a radionucleotide decay that was vastly accelerated during the flood. So what he proposed in his model was that he looked inside and found both argon and helium diffusion rates were too high when we looked inside of zircon crystals. And he said, well, look at this. If we have crystals that lock and hold in the environment and there's too much helium there, then how did this happen? Because it can't be there over billions of years. So what he did is he said, okay, I can see a problem. I'm going to look for that original image. If there's a lot of uranium and then it decays into lead, that takes a very, very long time. So we found lots of lead in zircon crystal, and that can only get there from lots of time, right? So, but then he found something that made it look young, which was lots of helium. Well, the helium can't be there for a very long time. So we have two things. We have something that makes it look old and something that makes it look young. So how can both be true at the same time? They really can't. So he proposed accelerated nuclear decay because that was the best idea to come up with at the time. I find accelerated nuclear decay a bit of a problem when we look at meteors, when we look at the moon, and then when we look at the Earth. We find that they date about the same. So what's going on? How can they all date the same? Did the moon go through accelerated nuclear decay? We talked about that the other night. Of course not. Did meteors and comets from other planets or break off and all hit the Earth and date exactly the same as the Earth as well? Why did they go through accelerated nuclear decay? It just doesn't make much sense. So I think it was the best explanation that they had at the time. Now, am I saying that no accelerated nuclear decay happened? Yes, some did, but we're talking in the tens of thousands of years, not millions and definitely not billions. And we're going to go over that today.
Right. I think that's a really good way to set the foundation for what we're going to discuss, as we are going to go through some of Erica's video as well. I would like to, before we play her video, I'd like to tackle the main source of heat and radiation. So as you pointed out, we have other issues other than apart from accelerated decay that would produce or generate heat and radiation. But if we get rid of the kind of accelerated decay, right, brother, that would be 500 million years plus worth of decay in a year's time. Right. Then I think we have many factors and solutions that would get rid of the heat due to plate movement, due to limestone formation, meteorites, and so on. And so if we can deal with the accelerated decay issue, then I think we have far less of a challenge on our hands in answering this question and major objection from evolutionists. Would you agree with that, brother?
Yes, because remember, if we're going to bring up heat regarding subduction being rapid, well, we would have to know what the ancient sea floor bed looked like. And as we know, it all comes down to viscosity when we're talking about plate movements. So that is why I have a picture right here that's showing that when rocks heat up, they expand over 10%. And so if we're having expansion of rock, we're getting the viscosity changes and movement can happen more rapidly without generating as much heat, because they can essentially, the continents can move over each other like an iceberg does on water, not generating as much heat, but moving much faster. So if the ancient seafloor bed was different than it is today, then there's also another factor, which John Baumgartner actually proposed. He said it was an ancient, colder seafloor bed. So again, we want to focus on the main problem, since this has kind of been resolved already with the math and the programs that I had somebody run for me. This one is really important because though there's different mechanisms proposed on how to get rid of the heat, either by pumping it into the earth or removing it into space, there's still a lot of heat to deal with when we don't even need to go in that direction. And that's what I think most people don't know. We don't need to invoke 600 plus million years of accelerated nuclear decay in the flood at all. It was just his old idea. And now we have visual, testable, repeatable evidence that shows us we don't need it at all. And that's what we're going to go over today.
Yeah, I'm going to share my screen and tell me what you think, because I've been doing a lot of thinking on this. And we've discussed the possible evidence for accelerated decay. You covered just one, the helium in zircon crystals. as uranium decays into lead, a byproduct is helium. And helium is a very slippery molecule. And so it should have dissipated into the atmosphere. If these zircon crystals are billions of years old and uranium has been decaying into lead for that amount of time, we shouldn't have all of this helium and all of these different rocks in the geological column, right? And the fact that we have a lot of helium present, and yet we also see lead, okay, if we assume that that lead came from uranium, then those who do hold to accelerated decay, right, Matt, they would argue that, okay, we have evidence for a young Earth and an old Earth here. But how do we explain, in light of an old Earth, all of this helium that shouldn't be there? It should be gone. And the higher the heat is, the higher the temperature is, from my understanding, more helium is going to be removed and dissipate into the atmosphere. So if we have all this lead, which suggests a lot of decay, but also all of this helium, well, the natural conclusion would be that we had 500 million plus years of decay in a year's time, in order that all that helium could not escape. So all that helium is there because a lot of decay has happened, but that decay could not have occurred over billions of years, or else the helium would be gone. So the fact that the helium is there means that the decay occurred quickly over a short amount of time, right, Matt? Is how the argument goes, basically. So that is a very interesting, fascinating argument. And the responses from the critics have largely failed. Dr. Russell Humphreys, who made this prediction, he gave a presentation just a month or two ago, technical presentation, really interesting one. And he pointed out that the critics have done their best over the years since this finding, and none of their responses have been satisfying. None of them have made it into the peer-reviewed literature. None of them have really been tested in the sophisticated manner that Dr. Humphreys and the rate team's argument has been with helium and zircon crystals. So whether you invoke accelerated decay or not for that observation, for that reality, it is truly an undeniable line of evidence for young Earth, because in the general sense, there simply should not be any helium present in rocks and zircon crystals that are a billion plus years old. That helium should be gone. Okay. So in general, it's a solid line of evidence for young Earth. The critics have failed to address that evidence, and the criticisms and objections that have been brought forth, Dr. Russell Humphreys has addressed. He's addressed all of them. He's left no stone unturned. And so before just to keep it focused then, Matt, and I know you touched on this, before I get into my thinking on the invention of radioactivity, if the helium in zircon crystals is not to be explained through accelerated decay, but the lead is there, how did the lead get there, brother?
Great question. That's actually what we're totally going to cover right now.
Want me to share your screen?
Yeah, share my screen, please.
Okay. And I think this is good to set the foundation for when we respond to Erica's video, because that way we don't have to take too long of pauses. We're kind of setting the foundation here, and then we'll see what Erica says and argues. And then at least up to this point, the audience has seen a lot of the pertinent information that applies to this topic. So Matt, go ahead, because this is a major issue, right? Helium in zircon crystals gives us just a truly incredible evidence for a young Earth. Right. As I said, during this process of uranium becoming lead through radioactive decay, right, helium, which is a gas, helium is produced, and helium moves through rocks, since rocks are porous, and gas can escape through these rocks. And so since we find an abundance of helium as a byproduct of uranium to lead, that helium should not be there. It should have had billions of years, gives the helium plenty of time to leak through those rocks. And yet we see an abundance of helium. So if the Earth was old, that helium shouldn't be there, but yet it is there. So one, it is an evidence for a young Earth, but is it evidence for accelerated decay, or is there another explanation within the young Earth creation model? Matt, let's throw it to you, brother.
Absolutely, because you have to think about helium when we buy a balloon. Helium rises, and it's a very slippery element, gas. So it can escape from a zircon crystal, whereas nothing really else can. So if it can remove itself from a crystal, and the hotter it gets, the faster it dissipates. How come there's so much of it in there? And so that really made the scientists go, wow, there must have been something to either accelerate it, or it was all created recently with that in there. But since, remember, lead can't get into a zircon crystal because the crystal can't grow in the presence of lead, then the lead that's inside of it had to have come from the decay process. So they say, that has to prove it's billions of years old. So the very first person that we're going to talk about here, Ludwig, he worked with a cold fusion. Now, a lot of critics don't believe in cold fusion. That's okay. This is the formation of radioactive elements or any other element, because they're trying to make gold, diamonds, anything very lucrative. This process has been going on for quite a while, but this was the first person to actually successfully make a element using cold fusion. And this happened in 2005. And when he formed iron, the ratios of iron that formed were as they are in the world today. Not some disproportionate ratio, but exactly as we find them as they are today. Now that's going to roll over into the radioactive elements that we're going to be talking about, because that's what's used to date the age of the earth, meteors, the moon, really anything that has obviously radioactive elements to test. And so he got a job later working for the Proton 21 laboratories. Now this laboratory is no longer in existence, unfortunately, because being in Ukraine, it's a war-torn country now. So these experiments, unfortunately, have stopped. But while they were working there, they repeated this process multiple times. You can find things on, just search Google, and you can find multiple examples of their studies. And what they did is they produced technetium 99, lutetium 177, iodine 131, and they were using these for cancer research and within tools and lasers for different companies. So clearly these weren't just studies where they made something and then just said, okay, just print it and let's pretend we're doing this and then we'll get popular and then we can make some money. No. This was actually something that was occurring all the time. They were using a process called Z-pinch. And they were basically using lightning to strike pure rods of copper. And when this happened, it produced the elements that we have on Earth today in a ratio indicative to what we actually see, not anything outside of that. And this is really, really important, because when we go back and we look at his first experiment where he produced massive amounts of iron that we find, this is really, really important, because you have to think even the evolutionary model has what's called enduring lead paradox. And if we look over here, we can read the bulk of the terrestrial lead isotopes to fit into the standard model of an Earth built about 4.5 billion years ago from meteoritic material. The simple solution to the lead paradox, which, by the way, is there's too much radiogenic lead to be there for the Earth to only be 4.5 billion years old, is to invoke a complementary reservoir of unradiogenic lead. In principle, the Earth's core could constitute as this reservoir, because they still don't know what the core actually is, but only if the lead migrated there or moved there to the core at least 100 million years after the formation of the solar system. So think about that. That's how old is our solar system, right? That's pretty old, a lot older than the Earth. So now they have to say that the Earth is much, much, much older. We're talking 13.7 billion years old now. So far too old. And we have an answer to that now. And it goes back to the Proton 21 laboratories, where we can see the only thing that was out of proportion, really, every single time, were the daughter elements of everything that was produced were in very, very high proportions. Now, this is huge and vastly important. If we see more copper daughter element form and we see it in zinc, well, what's going to happen now if we go, well, what about uranium? all going all the way down to lead. What's everything in between that? Because they're just thinking it had to come from uranium all the way down the decay chain. And if you start with that presupposition assumption, you are going to get the wrong answer. And we now can go, well, what did they assume? Well, they assumed that not much was produced, and very, very little bits, and it would decay down. What did we actually find? Massive amounts of daughter elements were actually produced. Massive amounts, far more than they ever expected. So when we look at the formation of this one in particular, which is aluminum, we find that there's tons of it that actually gets produced. Now, how can that possibly be? Because remember, that's supposed to be from the decay chain. That comes way down the line. It's not supposed to be something that's massive amounts of, but yet we're finding that. So what they expected to find was right here, a natural amount, but they expected the formation to be much higher. This is what they assumed. And what we actually found was the formations actually match what the laboratory found. And why didn't they form as they would have if they really existed billions of years ago and there was a decay chain occurring? They didn't. They occurred in the opposite proportions and what we find in the earth today. So how could billions of years have actually passed? And we find it even with potassium. We find the exact same amount of potassium we find in the earth's crust, and we find the ratios of them as in the earth today, from stable to radioactive, potassium 40. So again, what happened is, oh, great. Awesome. Zircon crystals trap the environment around them as they grow. So if they're going to be growing, and what we find is massive amounts of productions of daughter elements, then they're producing the radiogenic lead daughter stable isotope, lead 206, very, very rapidly. Because look at the half times of some of these: 140 days, 5 days, 22 years, 19 minutes, 25 minutes. So if these are being produced rapidly, if fast in massive proportions, and then the zircon is trapping them, well, you're getting lead produced quick. It doesn't take billions of years. So the observable evidence from studies.
Matt, just for clarification for the audience sake. So
Yeah.
so what you're touching on here is so important. Is this, correct me if I'm wrong, is this analogous to, which we're going to get into, if God created the original rocks with a mix of these atoms, right? Uranium, lead, and all the decay products, everything that leads up to lead, for example. This is an example of what those ratios would have looked like at creation.
Right, exactly. We're mimicking in the laboratory what the creation event would have looked like. So if God on day 1 and day 2 was creating all of the elements from radiogenic to non-radiogenic, aka the material that's in the ground around us today, including the dust that we're made out of, the radiogenic elements would also be there. And so what proportions were they in? Well, I'm going to go with what the lab says. And with what the lab says answers the paradoxes that evolution has. It answers the heat problem that the Young Earth creation model has. And it gives us an indicator of how old the earth is without any assumptions, because we see literally the decay chain forming in the opposite proportions that they expected. They expected a change.
So the alternative would be what? God creates just uranium. Let's take uranium to lead. God just creates uranium. And so all that lead has to come from uranium in 6,000 years, with most of it coming during the flood through accelerated decay.
Right. Which would be devastating if the laboratory tried to produce anything that was radioactive and all it produced was uranium. Yeah, we would be like, uh-oh, I don't know how to explain that now. So God must have done some type of a miracle. But instead, we get an answer to this problem, which is the zircon crystal literally stored the memory of what the earth was like when it was created. And how do we know? Let's go to the Bible real quick, actually, because the Bible says something very interesting. It said, God said, "Let the waters under the heavens be gathered into one place, and let the dry land appear." So if that's true, look at this. There was a study that actually showed that in the beginning, this study provides evidence of a non-mobile, meaning not moving, lithosphere, meaning the land mass itself and the ocean. There was no mid-Atlantic ridge moving. There was no subduction occurring. A stagnant lid of tectonic activity globally, all the way back to the original period of Earth being created, right? So that means that in the beginning there was no plate tectonic movement. What did the Bible say? One land mass, one ocean. Look at that. Exactly what the Bible says. It was a Christian that came along and said, look at that. It looks like the continents fit together and Pangea, and that they must have moved and separated later. And guess what? The creationist was correct. And so that actually destroys abiogenesis, by the way, because hydrothermal vents to start life in the bottom of the ocean require heat. And you don't get heat without subduction. So how do we know? When uranium isotopes in ancient grains indicate that early Earth was actually less hellish as well. So guess what? When we look in the zircon crystals, we don't see any magnetism change. So the continent was not moving. Nothing was moving at all. Then what else do we see? Uh-oh, look at that. Massive amounts of oxygen, and there was water, and a stouty, solid, temperate, meteor clear, watery world, and Eden from the beginning. And these are not Christians writing that, by the way. These are secular. This is as secular as it can. Matter of fact, it's Wired magazine. That's where I first found it, from Elizabeth Bell. So if the secular community is finding what the Bible describes, and then we look in these zircon crystals and we find that it's showing evidence that it's young, and then we go to a laboratory experiment that answers why it's young, then we look in the zircon crystal and then we find no magnetism. It shows us that the Earth was actually not as it is today, but a solid unit that didn't move. And then we find that it was full of oxygen and water, and it wasn't hellish, because remember, Earth was supposedly created from meteor bombardment and volcanism. They found the exact opposite is true. So literally everywhere we look is answering the heat problem for us, and it's telling us how old the Earth is. It's pretty cool. Unfortunately, the laboratory is gone now today because of.
Now, Matt, in a nutshell, and pause there and then keep going in a second. I'm saving a bunch of questions. And so with the origin of radioactivity, again, we're going to touch in more detail on that soon. The Proton 21 lab results and data give us an idea into how these elements, how radioactivity could come about through special creation at the beginning. So creation myths here, appreciate the engagement. So he says, sorry, he's not following. And so maybe we can reiterate a couple points or break it down a little bit differently. He says, how does this solve the heat problem? Where does the heat go?
Well, the heat was made from 3 different things, and we're only talking about accelerated nuclear decay. We're saying that accelerated nuclear decay barely needed to happen at all. We're talking about tens of thousands of years. Answers in Genesis creation, catastrophic plate tectonics is invoking 600 plus million years, which essentially melts the Earth 5 times over. So me and you, Donnie, are trying to help them. We're trying to solve the problem for them. And we're showing a laboratory experiment that shows that the ratios of the radioactive isotopes when they form don't have to go through a massive decay chain from uranium and thorium all the way down to lead to be stable in a slow process. They can actually form in massive amounts of daughter elements, which are decaying within hours, days, weeks, months.
Okay, so this experiment is demonstrating that your parent and daughter elements, massive amounts of daughter elements, are formed instantly in various ratios, and so they're all decaying from their initial states and decaying rather quickly, because we don't have to go through the entire chain as you would if it was just uranium.
Right, exactly. And what's happening is they're being trapped in the zircon crystals that they were created early on in the days of creation, not during the flood. So that's the difference, is they're trying to force a 500 million plus years of accelerated decay in a single year, because they didn't have any examples of what any radioactive element would look like if it was actually created. But
okay, so there's not this incredible amount of decay occurring during the formation of these elements at creation or in the experiment here, which is giving us an idea into how the creation could have looked like. We're not getting 500 million plus years worth of decay in a short amount of time. So yeah, heat is produced through decay, but we're not getting this massive amount of decay that you would with accelerated decay.
Right, exactly. You need accelerated decay if we're starting with the assumption that it has to go through that whole decay chain of 4.5 years. Absolutely, far too much heat. And catastrophic plate tectonics has to invoke God did it. Me and you like more naturalistic answers. especially if there's evidence for it. Now, the Proton 21 laboratory using lightning to strike copper, pure copper, and getting a plasma discharge showing different elements forming, and the elements that are forming as they are today, not as they would have been billions of years ago, then it's a good argument in our case, I believe, to say, well, a billion years could not have passed, because if they would have, then the ratios that were formed at the observational studies would have been completely disproportionate with what we actually do see.
Okay, so how do you respond? So creation myths, again, we appreciate the critics and their engagement. That's what we're here for. That's why we do them live. So he says, and let's pretend you're sparring with him in the debate octagon. So he says, but Matt, if it happens instantly at creation and with the Proton 21 laboratory here in Ukraine, that is by definition accelerated.
Okay, sure. But day one of Earth could have looked like this. I don't know. There was no life yet. It didn't matter. So if there was accelerated nuclear decay going on in Earth early on, it wouldn't have hurt. There was no plants.
Yeah, but if these daughter elements are formed instantly in an abundance, okay, well, they're not forming.
They're not accelerating.
Parent to daughter. So how would that be accelerated? They're formed in those ratios.
Exactly. It doesn't have to accelerate. They're already in a higher proportion that was assumed, and they're just decaying at their normal rate, which is by minutes, days, hours, weeks, and they're decaying rapidly, forming all that lead that we see. It doesn't need to be acceleration at all. That's what's so good about this. It answers why there's lead crystals.
Are they formed? Okay. Are they formed in those various proportions and ratios, and then from there the decay starts?
Yes, exactly.
Okay. So if they're formed in those various proportions, then you don't need millions of years of accelerated decay to go from uranium to lead if those daughter elements are created instantly.
And it explains why everything that we've ever dated, from every meteor to the moon to whatever, it always dates the same age.
So was there a massive amount of heat? Was there a massive amount of heat produced in these experiments from the proton?
Yeah, they used cold fusion. So apparently it was formed what's called adiabatic. So the machines that produced it, though they formed massive amounts of heat, they also absorbed that heat, and the machines were cold to the touch right after. So though massive heat was there, it was also cool again immediately. So it was
a massive amount of heat, extremely hot, but then cool within seconds, like some kind of canceling out effect.
Exactly, called adiabatic. And that was what was unique as well, because those machines, obviously you couldn't even get near something like that with Z-pinch going on. But if the machines themselves cooled right back down afterwards, it was pretty amazing. Matter of fact, the machines made all kinds of unique things, elements that only last for seconds and then they completely disappear. We don't even know what they are or name them.
It's just instant cooling. Elements created, a lot of heat for a second, and then instant cooling.
Right. And yes, exactly. And we didn't have to invoke accelerated nuclear decay in any of it. We don't have to. There's no accelerated nuclear decay on day one. There's no accelerated nuclear decay really in much of any place. If it's going to occur anywhere, because of the evidence that they found with the halo tracks, we only need about 150,000 years of accelerated decay. Very easy to explain. And
this was done naturally in this experiment. These ratios were formed. Okay.
Yeah.
If someone were to say, like Dr. Joel Duff, appreciate the comment, he says, must say miracle. It's not that hard. Well, was it a miracle with this experiment?
No, that's what's so cool about it. The experiment literally produced things that they've sold. Like they took their daughter elements that were forming in these high proportions, and they're like, look, we can sell them in the laboratory. The medical, you can't make more money in pharmacology and medicine. So they were literally selling their massive ratios of daughter isotopes that have a fast decay rate with machines that they were building, lasers. And so they were literally taking this experiments, their results, and then taking them and making money from them. So it's not some myth. It's not like, oh, they believe in cold fusion. Oh, they believe this nonsense. No, we believe a laboratory experiment that got great results.
So,
and then we just go with it. Just obvious.
right. So this is your expertise. You wrote a book on it. So I'm curious, from this experiment, would it be accurate to say that this experiment mimics what the special creation event could have been if God created instantaneously these atoms?
Sure. Yeah. I mean, if the Earth is really run by radioactive elements, uranium, thorium, some say no, there's none in the core. Maybe it's just potassium. But you notice that all of them are radioactive. So they must play a purpose. They must have something to either help with the Coriolis effect of the Earth. They must to generate heat and the convection to keep the planet going. There's some reason that they exist. So some people say, no, there was no radioactive elements. They formed later during the flood. It just doesn't make much sense, because when you go buy soil somewhere, what do you buy? You buy NPK. Well, the K is potassium. You need potassium for plants to grow. So how are plants growing on day 3 or 2 if they literally didn't even have potassium in the soil? So, it's no big deal for us to say that they were formed on day 1. It's just
right. And there's many practical reasons. And we have an example of how this could have happened with this experiment. So creation myths, then, in light of what we're saying, and I think there's an easy answer, Matt. So he says, how would that heat dissipate in like 3 literal 24-hour days? You still have a heat problem. But didn't this experiment just demonstrate that no, there's not a heat problem?
correct. And that was with the machine. But remember, if there was no life and there was nothing, how long would heat have to dissipate? Was there an atmosphere to the Earth? I don't think so. That didn't really happen on day 1, did it? In Scripture, was the atmosphere already there, or did God create the Earth and then form everything after that? Because if there's no atmosphere, then it's literally going to get dumped into space.
Yeah, after the fact, he breaks up the heaven into 3. So you got the sky, space, and then obviously we have the 3rd heaven where God is. So
unfortunately, it's too vague then to tell us. It's only the people that are like us that are trying to figure out, like, when did some of these things happen, so we can give a good answer. But it's unfortunately sounds too speculative. But I would place that if you're going to have an Earth that God's creating these things on particular days, that these obviously the elements are going to be created at the same time. So if they're going to be created at the same time, it would make sense that the heat is already there, because zircon crystals form in heat. And if they form in heat and they're trapping the environment that's around them, and obviously I think that it happened in early days of creation, because remember, the zircon crystals don't show any magnetism change. So therefore, Earth had no tectonic plate movement yet. And yet there was still water, there was heat, there was life. It was just, it's an amazing world. And it's very, very different than what we would assume in the growing up believing in evolution. We were told, no, it was a molten ball of lava. And I just
technically speaking, on day 2, that's where God creates the firmament, the rakia, so the atmosphere. And I still don't fully understand why this would be an issue, because Joel Duff says even without an atmosphere, you aren't going to dissipate that much heat in a few days. I mean, you're having the instantaneous creation or formation of parent and these daughter isotopes.
Yeah.
So it's again, these daughter elements like lead are not at that point coming from the parent form like uranium. So there's not all of this accelerated decay occurring. It's happening instantaneously, right?
Right. But what they're saying is that Z-pinch made these elements. So if God used Z-pinch to do it, there's still lots of heat. Even if it's adiabatic, what's happening to the heat? I said if there's no atmosphere, it's just dissipating immediately into space. There is no atmosphere to trap it and hold it in. It's literally leaving directly into space. Then the very next day, there's an atmosphere. But now the world is good, and everything can now start to work. You can get plants. Then it's even before the sun is created.
Yeah. So even before, obviously, you have humans and biological life forms that would be negatively affected by that.
Right.
So let me go over a couple different things here, because I think we're doing a good job setting the foundation and giving us a starting point to respond to some of Erica's claims. So I'll ask you a couple questions here too, because obviously it's a technical issue, deserves a technical response. And so I've been doing a lot of thinking on it, and we did a show with Kent last night, and we wanted that to be shorter. We wanted it to be concise, just a shorter response to this issue that people can benefit from and pass it around, those that might not want a 2-hour video on the topic. So we did that with Kent. I do recommend people check that out. And so we talked about the necessity of accelerated decay. Is it necessary? Is it a necessary feature of the flood? And so I've got some notes here, and this, correct me if I'm wrong, this would fall in line with what you're saying in terms of the proton laboratory experiments. And so the invention of radioactivity was likely a deep rock phenomenon, as long as there's usefulness to radioactivity, which we understand there is. Its intention was to keep the earth warm. This would also, from where there's no sun, right? Because at first God just creates light, and then eventually you get the sun. And so it would keep the temperature of the earth stable during creation week and in the pre-flood world in general. It's only after the flood, so the fountains of the great deep break open, and that radioactivity is now brought to the surface to become a major threat to us. So that does work. But Erica, in her video, she's going to put forth 2 major objections to that. I don't want to address that just yet. We want to get to it in the video and address it. Okay. Mm-hmm. And so, Matt, with the Proton 21 lab, what have been the major objections that you've heard to that? You know, I've heard some people say, well, it's not running right now, or it's difficult to see the work that they're doing, or they haven't followed up on it. And so a lot of people doubt the data from those experiments there. What would be a good response?
Yeah, I would say that the best one that I heard is that, well, it was in a plasma state. So therefore, any of the creation of these elements would require massive amounts of heat because it was plasma. Same thing with accelerated nuclear decay. If you're accelerating nuclear decay in these studies, they're done when it's in a plasma state, which is extremely hot, by the way, like literally molten. So what's going on when they recreate the radioactive elements is there isn't a plasma state that's there. It is just a lightning effect from the Z-pinch and pressure and what it hits. It has to hit something. Apparently they chose pure copper. Pretty much a good choice, actually. I don't know why they chose it, honestly. They never said, but that worked really good. I guess there had to be a point of contact to do something, and then it created a splash of plasma. So now, does the whole planet have to be plasma for Z-pinch to work? No, of course not. But it will create a plasma ball, which is now creating these things. So a lot of people don't actually believe it because they use the word cold fusion, and a lot of people don't. They go, cold fusion, nonsense, creating those things. Well, I'm sorry, but the experiment did show their results, so they do work. It just comes down to, do they actually trust it? That's why I showed their results, that they used medical equipment and created them with their results. So it's not just that they wrote a little paper and said, look, we did something that no one else has ever done. No, they proved it. So
okay, now
I also have a lot in the book, by the way. Critic questions and comments and arguments. So
you did a couple. Well, you did at least one debate too with Grayson on this issue that I'd recommend people check out, and that was over 3 hours, so it's comprehensive. So Wesley Coleman, appreciate it, brother. He's got several comments, but this one kind of sums it up. And so let's answer this one. I've got it up on the screen, and we can answer it in the form of an elevator pitch. Just really break it down for anybody that's been following us for the first hour of this show, and they're wondering, in layman's terms, I guess, in a clear and concise way. So Wesley's wondering, I need you guys to answer in a concise manner. What is the heat that we're dealing with from Z-pinch? And then he asks, is it not the same as accelerated decay? So what are the differences here? Why is this a better explanation than accelerated decay, what we're seeing in Z-pinch? And how does it relate to the overall problem here, Matt?
Okay. Z-pinch is like this gigantic tube that has lightning that can flow through it. And it's a plasma confined system that uses electrical current, aka lightning, to generate a magnetic field that compresses the plasma into a direct line. And this Z-pinch system is used for all kinds of different things, usually intense X-rays, but they've used it to contact a pure piece of copper, like 99.99% pure. And when it hits it, it releases a plasma discharge that now has new elements that were not present. Remember, only copper was there. Now there's new elements that exist in different proportions and ratios. And when they looked at those ratios, they mimic what we see on Earth today. So I thought to myself, wow, if they're producing calcium and lead and all these different things, I'm like, wait, what would happen if I looked at what they produced radioactively? So if they produce radioactive elements, then that we can use that to see what the ratios were and use it to judge how old the Earth is. And lo and behold, they produced radioactive elements like thorium and potassium that are in the ratios that they are today, not as they would have been billions of years ago. So there was no decay, because we would have seen it in the experiment. Now, the ratios would have been much higher, but instead they're the same. So then when we go, okay, well, what about the daughter isotopes that I looked at? They're off the charts, like I showed earlier. Their ratios are much higher than the parent. So therefore, when you're looking at radioactive versions of the daughter elements, they are rapidly decaying, and they're creating all of the lead that we find in the zircon crystal. And so it answers, we don't need accelerated nuclear decay now, because we don't have to have those high proportions of parent isotopes. We have massive amounts of daughter isotopes that are rapidly decaying into lead. So there's no need for accelerated nuclear decay, which takes away the biggest heat problem for catastrophic plate tectonics. If you don't like the model, you don't even need to believe it in the first place. But I hope that answers that. I mean, there's plenty of flood models. If this one bothers you too much, don't believe it. It's fine. It's a good one, but they have problems. This is one of them.
I think the most important part that you're pointing out there is that these ratios mimic what we see today. And so that right there is an important point. And the critics, as Dr. Russell Humphreys has pointed out, I'd like to see the critics view his latest technical presentation on helium in zircon crystals. Dr. Russell Humphreys has pointed out that all the critics have failed to address this amazing evidence for a young Earth. So if you can have helium and zircon crystals, which demonstrates a young Earth, because if the Earth wasn't young, that helium in the amount that we find should not be there. But also you might not even need accelerated decay to explain the presence of all that helium. Now, hypothetically, just to brainstorm here, let's say it was due to accelerated decay. Okay, well, if the best and most parsimonious explanation is accelerated decay for all of the helium we find in these zircon crystals, and the evolutionists can't account for that in an old Earth, then even if we need a supernatural explanation to explain the accelerated decay and then also the removal of all that heat, okay, well, the evolutionists can't account for that in an old Earth. And so that would just be the best explanation. It's not like the evolutionists can say, well, that accelerated decay would create too much heat. You don't have an explanation for the heat. But wait a minute, you don't have an explanation for all the helium present. And if the best explanation is accelerated decay, then maybe the best explanation for the removal of that heat is a supernatural one. Does that make sense, Matt?
Yes, but remember, we're talking to people that don't want to hear a supernatural explanation. So me and you try to go out of our way to find if there is a better answer. And we can invoke, like, okay, well, do we have an example of a resurrection? I would say yes, but a lot of people would be like, no, we don't. So therefore, it's not true. It didn't happen. So a lot of people just believe it on faith. Okay, that's part of it. But some people, remember, some people need answers. They need it to believe. So that's where you and I come in. Remember, it says greater is the person that has more faith, right? Their reward will be better. But that does that
mean, I want to point this out. See, Andrew Cummings not getting it. We're providing them an explanation that doesn't require accelerated decay, perhaps.
Oh, he just joined them.
So he says, so you are appealing to miracles then. Gotcha. No, you missed the point completely. It went over your head, Andrew. just like all the points when it comes to ERVs and Y chromosome. If accelerated decay is the only explanation, as someone like Dr. Russell Humphreys, more than qualified scientist, would say, for the helium present, which means the old Earth creation model can't account for it. And so only accelerated decay can account for it. The evolutionist has no counter to that. Now, what do we do with the heat? Well, it doesn't take away from the fact that accelerated decay is a reality, just saying if we were to go with the rate team, okay, then maybe the supernatural explanation is the most parsimonious one. The evolutionists like Andrew can't just say, well, you have to invoke a miracle. But wait a minute, what's your explanation for all the helium? And then the explanations that they've provided have already been dismantled and demolished and decimated by Dr. Russell Humphreys in written form. Let's see them counter that. That's the point I'm trying to make, Andrew. They want to just hand wave away this challenge by saying, well, the heat, though, you're going to have to invoke a miracle. Well, maybe a miracle is the best explanation, just like a miracle is the best explanation for the earth, the universe, life. Okay, so that's the point I'm trying to make. But if you don't want the miracle, Matt is pointing out here that there could be another explanation for the helium that doesn't require accelerated decay. Is that right, Matt?
Correct, because the helium would be forming just like the lead would be, because it's the daughter isotope of almost the entire decay chain. So every time there's a half-life, for every single one of those elements in between uranium and lead, it's producing helium. That's why there's so much helium in the zircon crystal and why it hasn't escaped yet, because remember, it's a slippery gas that can get out. And the hotter that zircon crystal gets, the faster it can leave. Well, why is there so much? There's still a ton in there, and it shouldn't be there, especially if Earth was a hellish environment for the early stages and then billions of years. I mean, these crystals go back to the earliest ages of the Earth, right? Apparently over 4 billion years ago, when Earth was literally molten. So how could there possibly be that much helium in there if the helium would be leaching out so rapidly during that time?
Yeah. And Jamie Russell says, if your browser can handle that many tabs at once without crashing, then the Earth can handle the decay heat. So that's a great point, Jamie. And I'm impressed, Matt, with the amount of tabs that you have open.
Baby boomer tab guy.
Yeah. Yeah. So, okay, I'm going to ask you this question, brother. And because I got to run upstairs real quick and fill up my water.
Okay.
And then we're going to get into some of Erica's points here. But I know you have slides and visuals here. And so I want a somewhat thorough answer, because Erica's response would be, okay, so I'm going to put my screen up real quick. So if we have the invention of radioactivity, where and when we say, okay, the question would be, what was the composition of these original rocks? The first rocks would have had certain ratios of atoms in them. If scientists came along shortly after the creation of these rocks, if they analyzed them and chose to date them, they'd come up with false dates of millions and billions of years, because those rocks were just created with those ratios. Okay, there would have been lead in those rocks to begin with. So do we require accelerated decay? Not necessarily. And if we don't, then that removes the biggest heat budget and radiation issue. And so if God created a variety of animals and plants, which we know would have been the case for theological and scientific reasons, right? Created heterozygosity. That one's for you, Dan the man. And so if design diversity, okay, is a reality, scientists come an hour after creation and they genetically sequence Adam and Eve in the original created kinds. Well, they're going to find DNA differences. Okay, this goes back to basic genetics and alleles, right? Capital A, lowercase a, capital B, lowercase b, you'd be genetically what? Heterozygous. Capital A, capital A, capital B, you'd be genetically homozygous, okay? So God said, be fruitful and multiply. He didn't say be fruitful and clone yourself. So created heterozygosity, Adam and Eve being created in a state of DNA diversity makes sense. And it also results in predictions. We can talk about that all day. Okay. And so again, you have pre-existing DNA differences that scientists would erroneously conclude were inherited from past common ancestors. They would conclude that Adam and Eve and the original created kinds are old, as in they have ancestors, a long history of ancestors, even though they were just created. This is the same thing with the rocks. You were to date those rocks that have uranium and lead in them, then you're going to conclude that these rocks are millions to billions of years old, even though they were just formed. Okay, so these errors come from the erroneous starting point, the presuppositions of the naturalist, of the evolutionist. Okay, because if creation is true, then of course God is going to create trees, and the leaves on the trees are going to have chlorophyll in them. Animals and plants, they're going to have pre-existing DNA differences, or else they're just going to clone themselves. God would create the rocks with uranium and lead atoms. This makes sense. There's good reasons for it. Okay. And then at the flood, the radioactivity comes to the front when the forefront, once the fountains of the great deep break open. So Erica's follow-up that we'll see in the video, but I know you got some slides and visuals ready. She says, well, this can't be the case. She kind of grants it for a second. Okay, let's grant this. But this can't be the case because the flood would mix everything up. And so we wouldn't find the ratios, the proportions that we see today. We wouldn't find rocks at the bottom of the flood being older than rocks at the top. We wouldn't see this law of superposition, basically, a reflection of that. It should be all mixed up. So because we find that order, basically, in terms of the elements, the isotopes, then that can't be the case. And so, yeah, the lead must have come from, during the flood, accelerated decay. So, Matt, that's the main objection. If we can deal with that, then we've won. Will they tap out? No. But we've still given a sufficient answer, Matt. So what's the best way to address that, brother?
Sure. Well, first off, what is amazing is that you were right. When the Proton 21 laboratories created these radioactive elements, guess what? If they dated them based on how old they were, they would have appeared exactly as we see them today, which is billions of years old, even though they made them yesterday. So that's the fascinating part. So we have to say, okay, well, the ages that we get from them, though they're not true, they still make a great clock. If you had a watch that was uranium decay, I wouldn't recommend putting on your wrist, but it would tell you an amazing time, because they do tick down once after their formation anyway. They do stabilize and they do tick perfectly. That is why the assumption was that they must be really old, because of the ratios, not because, and that they tick at an accurate rate of time. So therefore they make great clocks. Now we know their starting position because of the experiments, and they don't have to be billions of years old. That's what the laboratory showed. Now, as far as the geologic column and the rating of that, that is true. You're right. Each rock layer of sedimentary rock is younger than the layer below it, but older than any layer above it. So what's going on now? Again, we're going to go back to, ignore that arrow, Russell Humphrey and the rate team. What I proposed, and then I found out that the rate team did as well, was that the atomic mass and chemical elements are indicative of, if you were to have a flood of something, or have a bucket and it's got a bunch of sediments in it, and you were to shake it up, if you were to put radioactive elements in there, would they be distributed and get as their atomic weight would be? Would uranium be on the bottom? Would it be deeper? Would it with thorium? And then would argon and potassium be near the top because they're lighter? And the answer is yes. And that's what the rate team discovered. And it wasn't the only one. This next study from the national, actually, who, I don't know actually who they are. This next study essentially did a follow-up test on this, and they found a systematic pattern in radioactive isotope discordances, exactly like the rate team did, where the heavier isotopes tended to yield older ages. In our study, we found the exact same pattern, and this shows you what that actually is. So first, we're going to go by the color right here, the lighter color being lighter at the top, and the darker it gets, deeper. So the color of each data point represents the atomic weight of each parent isotope, as given by the legend of the right-hand side of each plot. So what we're going to do now is we're going to show you that when they tested the same rock, but different elements in that rock, they found exactly what we would, is my image not coming through good? Hold on, I'm sorry. I cut it off. Okay, my bad. So what happened is, here is lead and rubidium and strontium giving the same date. But here, uranium and lead, which is deeper.
Matt, pause. Just to leave no stone unturned and not let any comments fly by. creation myths seems to be implying with this comment that something you said is false. So let's see you counter it. So he says the uranium would be lower because it's heavier. So he's quoting you, and then he says, my man. And I say, Dan, my man with the plan. He says, come on. So I am interpreting that as him disagreeing with what you said there. What's a good response?
Well, that was what I showed earlier. I literally showed their very statement itself saying that heavier isotopes yield older ages. And that's what we're seeing. We find that they're deeper in the rock, they're lower, and they also have discordant ages. So they don't even agree with each other. You can test the same rock with different isotopes, and they give a different age in the same rock, with the heavier elements dating older. That's literally what we see in the study. So it's not a myth, and it agreed with the Young Earth Creation rate team. And when we looked, it wasn't in just one type of rock.
So if he disagrees with this, he's disagreeing with something that has been substantiated, you're saying?
In studies, exactly. But unfortunately, remember, it came first from Young Earth Creationists, so he'll never agree. So it's okay. Next, when we look inside of all of these rocks around the world, they all showed the same thing. So it wasn't some rare case in one type of thing. Now, does that mean that it's in every type of rock? No. And the reason why I believe it's not in every type of rock, just the majority of them, is because different rocks solidify at different times. So if you have a rock that's solidifying extremely fast, guess what? There's not enough time for distribution of the elements, right? It's like anything. If something travels at a very slow rate anyway, but something traps it really quick, there wasn't enough time for it to travel. But if they're solidifying and hardening very, very slowly at a much slower pace, well, there's plenty of time for the distribution of the elements. Well, the flood was over a year, and different rocks form at different speeds. And that's exactly what we see. And guess what? We can read problem after problem when we read from the experts what they say. Look, the fact that radiometric ages for rocks of known ages turn out to be so seriously inaccurate is a strong suggestion that one or more of these assumptions is incorrect. Correct. The starting point is what was incorrect. Because I gave a lot of examples earlier, but we focused on the initial quantity. But all of these major problems still exist. As a matter of fact, they even say that of the 8 assumptions, none of them can be considered to rigorously hold to any situation. Therefore, dating by this method is at best a hypothesis concerning the age of a rock, soil, or mineral. It is certainly not a scientific fact. So, and then look at all the comments that I found from different experts in the field that literally do radiometric dating that all say the same thing. Look at this. We're building a new generation of fairy castles and myths for the very next generation to play with. So if you're starting off with a false start, everything that comes from that is going to be wrong. And that's what we're seeing. But the Proton 121 laboratory solved that. But of course, most people aren't going to like it because it agrees with Young Earth Creation. That's not our problem. We're just giving our answers for people that actually do care. So anyway, that distribution is what we find in experiments because it is based on atomic weight, mass, and density, and the heavier atomic elements date older. So it's case closed. It's there. It's observable. There you go. You don't have to like it. It's all right.
I was trying to find, oh, here it is. So if people go to, and I appreciate that, Matt, this topic is certainly not my expertise. And so I'm not going to pretend I just fully understood everything you just said, but you sounded confident, brother. And the gist of it that I understand, my active research projects right now are mainly in genetics, focusing on ERVs and ancestry. But I did want to point people to, if you go to creation.com and you type in helium and Russell Humphreys, you'll find detailed articles. You'll find technical responses to the best that the opposing side has had to offer on this issue. Okay, so if you want to see them complain about the heat problem or radiation issues, force them to address these lines of evidence for Young Earth Or for some, depending on what model they hold to, Matt, as you've been saying, go with what model you feel is best, right? So if you go with a model that holds to accelerated decay and you point them to helium and zircon crystals, force them to give you an answer that hasn't already been systematically demolished. Okay. And so, in other words, Matt, you are making the case that the ordering that we find these isotopes in, or the ratios and proportions that we find them in the rock layers, okay, doesn't necessitate rounds of accelerated decay where the older rocks during the flood year, the ones that are laid down first, you know, those who hold the CPT would say that they experience more accelerated decay because they're a bit older than the rocks that were laid down last. And so you'd expect that order. Accelerated decay would demand the same order that the old Earth creation model would argue for. That's how they would explain it. And so, you know, earlier in the flood versus rocks later in the flood, they're going to experience greater accelerated decay. And so that explains the order. But you're saying that answer is not demanded by the data.
Correct. And we can answer this on observable studies from something else as well. For example, when we date the seafloor spreading, it's done from potassium argon dating. Now, this wasn't done in a laboratory, but it was done visually and in scientific experiments where they actually determined that the seafloor spreading should be completely, like, literally just thrown out, but their dating methods from it. And the main reason why is because if we look at this, we find that when lava flows out from a volcano and it goes into water, or even if it's underwater, the more it goes down, the more pressure and the colder it gets, because obviously you go deeper, it gets colder, you are now accelerating the dates that they give by a lot. And here we can see that. You can read about how they erroneously give older dates than they should. And then here we can see that ages calculated from these measurements with a sample depths of 22 million years for lavas deduced to be recent. Uh-oh, could that be true? Could that literally be something, that a lava formation that we see the lava flowing out, we see it flowing down, and after 5 years of it going down, we test it and it's all of a sudden 22 million years old? Completely impossible. Yet that's what the evidence says. So we can look at the seafloor spreading and just throw away the dates because we know that they're not accurate from testing, just like we can throw away the dates because of the Proton 21 laboratories. We see them form. We test them. They were made a day before. They're billions of years old.
Right.
Case closed.
Made a day before, and yet a billion years old.
Correct.
Well, it's exactly, it goes back to the point earlier that if they were to genetically test Adam and Eve and the original created kinds, they're going to conclude that these are old, that they have ancestors. They'll build family trees, they'll do phylogenetic charts. And it's like, wait a minute, Adam and Eve were just created, but they were created with pre-existing DNA differences.
Right.
Just like these rocks were just created with a mix of uranium and lead atoms. And why shouldn't they? Why wouldn't they be created that way? To address Andrew Cumming, we did a video recently with Dr. Jason Lyle. So he says, how do you distinguish between apparent age and actual age then? Well, this is, I think, a reification fallacy. Dr. Jason Lyle discussed this in great detail. He's written a book on fallacies. I recommend people check it out in Logic. And so something doesn't really look old. If you say the universe looks old, that's fallacious, because, Matt, correct me if I'm wrong, this is the only universe we have. This is not Marvel and DC Comics. As much as I love Marvel and DC Comics, you know, the multiverse is not reality, it's science fiction. Okay, so we don't have Earth 2, Earth 3, Earth 4, where we can compare this Earth to and say, oh, wow, this Earth looks old compared to the Earth in Earth 2, or this universe looks old compared to the universe in universe 2 and 3 and 4. Okay. And so, no, this is the only universe we have. This is the only Earth we have. So when Adam was created, he didn't look at himself and examine himself and think, oh, I look old. I look about 30 years old. No, because he was the first person ever created. And he would assume this must be what a person who was just created looks like. Okay. So obviously we have proxies, right? Where, you know, we can look around the globe. We can look at the 7 to 8 billion people, and we're going to have traits that we look at and conclude are signs of age. Okay. But again, what's your proxy for a universe? Do we have another universe? Do we have another Earth? So no, we can equally say the Earth looks young. The universe looks young. So it is fallacious. Okay. So Matt, I know we don't have an extraordinary amount of time left. So let's go through some of her video before we wrap it up, because I know you got to get to work, brother. Okay. Because we did, you know what? We dedicated about over an hour to our critics who we appreciate so very much here in the chat, but we do have a few things to go through here with Erica. So Matt, rather than being long-winded in a good way as we have been, we'll just give quick comments to what Erica's saying. Okay, brother? So let me quit sharing and go here, present audio, make sure it's coming in good. And actually say a couple comments, because I got to pull up her video again, because it seems to have exited out.
Oh no.
Tell us that joke you know.
Oh my. One.
See, if this was Dr. Dino, we'd be more than fine with jokes for the next 10 minutes. Okay, here we go. So let's pull it up here. As I'm doing that, you've done quite a bit in terms of defending this model. Have you seen anything worthwhile that made you pause and say, okay, maybe this explanation is not good? Or the major objections that we've, for the most part, gone over today, they have sufficient answers? Because we know that the evolutionists, the naturalists, they have their starting point. They have their presupposition. So everybody, regardless of the worldview, including us, you're going to have rescue devices. Everyone's going to have a rescue device because we got the same evidence. We interpret it differently. And so they're going to have to interpret major challenges that even may seem to preclude their theory, their story, okay, from being true. They're going to have a story. They can always come up with a story. We could always come up with a rescue device too, because we have our basic presuppositions. But the question is, are these rescue devices convincing? Are they empirical? Are they outlandish? Right? So have you seen anything that's made you pause and say, okay, maybe this isn't the best model, or you're pretty confident with it, brother?
No, I like it because remember, when the results came in, they weren't using it. They weren't trying to get the age of the Earth. It was just a side effect, byproduct of what the results were from the creation of these elements. I was the one that was like, wait, what are these proportions and ratios? And like, how would they test if they were just now used for dating? And it's like, wow, look at that. I just took it to the next step. It just made me think like, this experiment is kind of nice. But all they cared about was making money from it, which makes sense. I mean, obviously, it probably cost a ton of money to make the place and do the experiments. So sure, I really like that the experiments gave results on something that was totally unpredictable, and they gave results that were unexpected, and they didn't care what the results were. They weren't trying to influence it. They just looked at it, and that was the result. So I love it. People just don't really.
All right, let's go with this. I just saw a comment. I want to make a response to it. So Tyler West says, I forgot this was a response to Erica. They played so little of it. Yeah. So, well, I've seen her video now about 1.5 times. And so we've addressed her major points. We do want to hear her say them. But like, for example, I'm doing an ERV, a very detailed ERV response. And I welcome the critics to counter it, to state it clearly. And I've largely, in the parts that I've done so far, I've been doing them pre-recorded, because then I can focus just on the video. Once you do these live, like I did one of them live, you know, we like to leave no stone unturned. I like to interact with the chat. If the critics are saying something or objecting to something, we don't want to just ignore them. And so we end up spending most of the time engaging the chat. So when it comes to some of the responses I'm doing, I've been doing them pre-recorded, because that way you can focus just on the video. Isn't that right? So, okay, here we go. And Matt, you can audibly tell me if you want me to stop at some point too. We'll go quicker so we can get through it. Okay, brother? We're going on mute in 3, 2, 1.
Hello, my gentle and of course very modern apes. My name is Erica. This is my channel, Gutsick Gibbon, and what we do here is we talk all about different subjects in paleontology and biology, specifically looking at human evolution and primatology, and we debunk a lot of pseudoscience, and usually that pseudoscience is young Earth creationism.
Okay, I'm well aware that this is not a talent, but this is like the only thing that I can do.
To bring a couple of you out there up to speed who might be new here, young Earth creationism is the typically evangelical here in the West belief that the Abrahamic God created the Earth more or less in its present state approximately 6,000 years ago, and that the entire geologic column from the Cambrian to the Cretaceous, sometimes even later than that, as well as all the fossils and geologic signatures found within that geologic column, is the result of Noah's flood, a worldwide flood that killed every single organism on the planet besides the denizens.
And that's what the evidence suggests. We talked about helium and zircon crystals. We've put out plenty of videos on C14 and diamonds, and we've engaged their rescue devices with PhD scientist, Dr. Jason Lau recently. We've had numerous presentations and conferences on the Genesis flood and the worldwide evidence for the Genesis flood. I mean, we got rock layers that extend entire continents or even further. We've got marine fossils in landlocked areas that are far from the sea. We've got more than enough evidence to suggest that a worldwide flood did happen in the past. And all of your major fields of science, biology, genetics, astronomy. Okay, I challenge the evolutionary apologists of YouTube to engage our videos that we just put out on the James Webb Space Telescope, where Dr. Jason Lyle, the gold standard of science, is making testable and falsifiable predictions, and his incredible predictions were confirmed. So anyways, we could talk about that for hours to days. So let's keep going.
Of the ark, and that all of modern biodiversity is the result of the proliferation of those survivors. You might be thinking, who cares about young Earth creationism? It's 2024. Who out there is still proposing it? And the answer is many people, including the current Speaker of the House of the United States of America, who also writes for Answers in Genesis on occasion. Now,
Yes, many people. But guess what, Matt? The Bible, like with many things, predicted that in the last days, there's going to be scoffers denying 3 things: the creation, the flood, right? The world that then was being overflowed with water that perished, and the coming judgment by fire. So yeah, we have people like Gutsick Gibbon. Erica, we appreciate your videos and we enjoy responding to them. So keep them coming. And they deny these events that explain what we see in this world. So yeah, if you're going to deny, as the Bible predicted, the creation and the flood in particular, and of course the coming judgment, then you're going to erroneously interpret a lot of the observations and data that we have. So yeah, it is important that people see the evidence for young Earth creation and believe it.
My favorite arguments against young Earth creationism as an idea, and in fact, I would actually go so far as to say this is maybe my absolute favorite argument, just due to its simplicity and weight, its gravity, its mass. It's called the heat problem. And while many arguments against young Earth creationism do a pretty good job making it look implausible, this argument makes young Earth creationism impossible. And I would love to sit here and take credit for this argument as if I'm the one who came up with it, but it's actually the young Earth creationists who did a lot of the initial legwork for this massive issue with their ideology. I will take some credit, though, for popularizing the idea, at least here on YouTube. I have done a copious amount of.
So in light of everything we've discussed, Matt, for the first hour and a half, is it an impossible issue, or have we not demonstrated that there are plausible answers and solutions?
Yeah, there are other answers, and I just enjoy my own the best.
Yeah. I mean, we're just touching the surface of it, brother.
Right. There's multiple people have given different answers. I just like this one because it's a laboratory published studies that anyone can go and look themselves and see. You can't go wrong with that, right? I mean, that's the gold standard of what they want as well. Not just testable predictions, but literal laboratory, repeatable, testable experiments, getting the same results time and time again. How can you go wrong with that? It's funny because that's what they asked for. You give it to them, and now all of a sudden it's not good enough.
Right. Well, because we understand, right? Basic presuppositions, different worldviews. And the Bible predicted scoffers in the last days. So some people are not really looking for an answer. So we can provide an answer, as we have for just about every subject,
right.
But we can't expect, okay, based on the differing worldviews and presuppositions, we can't expect them to tap out and agree with that answer, because now it's up to them to either accept the truth for what it is or keep fighting it.
Of content on the heat problem specifically.
And up next, I don't know why I'm like this. Ooh.
Now, when you look at all of these different video thumbnails, it does show this ongoing battle between us and Team Gutsick Gibbon on this issue. And this is what needs to occur. You know, this is an ongoing debate. It's a technical and comprehensive topic. And so it requires comprehensive engagement. And so, you know, we do appreciate the critics that are willing to do that because it only helps to strengthen our model.
Or what's wrong with me? Stay tuned for more.
Which is kind of funny because my specialty is actually human evolution. I'm a fourth-year PhD candidate in biological anthropology, and some of the videos that I've made about the heat problem are just outlining what the problem actually is, while others are looking at attempts by Young Earth Creationists to solve the problem. I've been making videos about this subject for many years now, and collectively, these videos have garnered hundreds of thousands of views. But what delights me the most is when I creep into the comment section on any given Young Earth Creationism video, and if the video is sufficiently large enough, there will be people in the comments saying, no, this isn't going to work because of the heat problem, regardless of the topic of the Young Earth Creationist video in question. I love to see that. And it hasn't escaped the attention of some of the Young Earth Creationist organizations.
That's funny to me because if you think about it, they don't even know what the heat problem is. They just use it as an argument, because if they really think that the heat problem destroys young Earth creation, why don't they just acknowledge, like, well, it's an argument against catastrophic plate tectonic, which is answers in Genesis version of the global flood. Like, there's literally more than half the people that believe in Noah's flood don't even hold to catastrophic plate tectonics. So it's kind of funny that apparently that is what destroys young Earth creation for good, but yet half the Christians don't even believe it.
I think if I were to play devil's advocate, I think it's going to come down to each model. And correct me if I'm wrong, speak to this. Each model is going to require an explanation for the dates that we get for rocks. So why do we pick up a rock and get billions of years? And so the best model is probably going to be the model that can explain that without a ton of heat and radiation, right?
Right. Exactly.
So each model would have an issue to deal with in terms of heat because of the isotopes.
Exactly. Like, how did they get in the proportions and the ratios that they are today? And why are they used so readily? And why do they give the dates they give? We explain why they give the dates that they give. We explain how they got into zircon crystals. We explain the lead that came from them. And we describe their ratios and proportions that we find them in, and distribution, which is, like you said, the most important part. How did they get distributed?
And you've explained that we spent the first hour and a half explaining the distribution, explaining the functional reasons behind God creating the original rocks with a mix, uranium and lead atoms. But even if you go with the accelerated decay position, right? Dr. John Baumgartner, Dr. Russell Humphreys doing just truly fascinating and fantastic work on this issue. The critics can't just say, well, there's a lot of heat, so anyways, time to move on. No, you need to explain the helium and zircon crystals. Okay. And I know Erica, you know, she's put out at least one lengthy video on it. But again, Dr. Russell Humphreys, he's pointed out in his latest lecture, which is fairly new, a couple months ago, he pointed out that the critics have failed in their responses. And Dr. Russell Humphreys has in writing technical rebuttals and responses to those points. Dr. John Baumgartner, same thing. We had email correspondence with Dr. Baumgartner on this issue, and we were provided technical responses, detailed responses to their rescue devices on C14 and diamonds. So no, they have not adequately answered those challenges. So they can't just hand wave away those challenges because there may or may not be heat and radiation. Okay, so I just wanted to point that out. Here we go. For those just joining us, we engaged the live chat for about an hour and a half. And so it was comprehensive. We really interacted with the critics, but now we're primarily focused on Erica's video here. So
organizations, some who have explicitly been trying to solve the heat problem for decades now and have still come up empty-handed. Of course, we also see numerous responses from YouTube Young Earth Creationists who still tried to make the whole ideology work, despite the fact that we've got a physics-shaped problem burning a hole in the entire tapestry. But like I've said, I've done so many videos on the heat problem, so what could I possibly be here to say at this point? And the answer is, I want to make a case to you that I think the heat problem is killing scientific creationism. Now, let me be clear on what I mean here. The heat problem has already killed Young Earth creationism as a viable idea. A great many arguments within big S science actually do that, from biology to physics to geology to chemistry to astronomy and so on and so forth. What I mean when I say that I think the heat problem is killing scientific creationism is that I think this issue is killing the creationist enthusiasm for arguing that Young Earth creationism
I want to address one thing because I've heard this multiple times. Erica's going to say it in this video. Grayson Hawk in the house. I like that last name, almost as cool as Nicolas Cage. He says Baumgartner himself said that it requires miracles. Yeah, from his model, the CPT and accelerated nuclear decay, it requires a miracle. Okay. So that's what he says, and you respect him for it, and I respect him for it too. But then what else does he say? He says that the C14 in diamonds and other samples that are supposedly millions to billions of years old have not received adequate responses. Dr. Russell Humphrey, same thing. He's pointed out recently that the responses, encounters to helium and zircon crystals, are lacking significantly. Okay, so why don't you go believe them on that one and sufficiently engage those challenges and realities? So that doesn't magically solve the dilemma for the evolutionists there. So you don't want to have a double standard, you know? Okay, so here we go.
Is scientific. As a super quick, simple example, when someone asks how can you get all of modern biodiversity today in just 4,300 years, they'll point to examples of quick speciation occurring in the lab or in the wild currently, and then extrapolate that backward and say, see, if we can see this at play today in this particular example, then we can retroactively.
The instrumental, and I appreciate the engagement, the instrumental background argument has been addressed. There's papers and technical rebuttals to this, and we just put out a video with Dr. Lyle as well. So the C14 in diamonds and high levels, detectable levels of C14 has not been addressed. Neither has the helium and zircon crystals.
Apply it to all of life. And they'll do this with all sorts of different things. They'll point to small scale, unique geologic events with specific geologic signatures, like specific characteristics that denote this unique circumstance, and then apply that also retroactively to explain all geologic formations and phenomena that we have in the world today. The Mount St. Helens eruption laid down layers of ash super quickly, like over the course of a couple of days to a couple of weeks. So why can't we explain the entire geologic column, 4.5 billion years worth of history, in just the single year of the flood, or at least the last 550 million years worth of the geologic column in just the single Noachian deluge? Why not? The answer, I hope, is obvious, and that's that those ash layers from Mount St. Helens, again, have specific diagnostic criteria that we can identify and associate with this type of unique event. And surprise, surprise, we don't find those characteristics in the entirety of the geologic column. I can go on and on and on using examples like those previous.
So we've had flood boundary conferences. We've done one specific open mic with John Mackay and Joseph Hubbard, two geologists. And it's not only Mount St. Helens, the observations there, but they've got flume experiments where we've seen these layers form rapidly, all kinds of layers formed rapidly. So we have real-time experiments showing the validity of the worldwide flood, laying down these rock layers, most of them. And again, I pointed out earlier that we've got these massive layers of rock, sedimentary layers that extend over entire continents. They can be matched, right? These worldwide mega sequences, which means multiple local floods over millions of years at different times can't explain it, because we can correlate these massive layers of sedimentary rock, showing that they were laid down at the same time to be able to be correlated so beautifully. Then we got billions and billions of fossils within those rock layers. So it's not just Mount St. Helens, but Mount St. Helens gives us a good idea into how these layers could have been formed rapidly. But the flume experiments as well. I mean, you go ahead, brother.
It's just funny how we can give them simulations, studies, observed volcanic natural phenomenon, and experiments, and it's not good enough. It's funny, huh? Just ironic.
Right. I challenge any critic to give a detailed, either written or video rebuttal to our conference lectures with John Mackay. It won't happen.
Is too, but suffice it to say, the idea is that they want to explain the natural world simultaneously using a young Earth creationist perspective and science. They want to say that science supports young Earth creationism, and it simply doesn't. Their reticence to just point to a supernatural explanation, okay, like the flood was supernatural, and that's how we explain all of the geologic and paleontologic phenomena that we find in the geologic column. I think that that comes from their sort of residual desire to keep the idea of maybe getting creationism back into the schools alive. If they admit that part of this or most of this needs supernatural action, then they can't get this taught side by side along conventional science in the science classroom. So they have to hold on to the idea that, yeah, it's supported, and it is supported by.
We know what the Bible says. We know where this world is heading. What's that, brother?
I said, I like that's what bothers her. That's what bothers her the most, the political aspect, not even science. It's
Yeah.
not what the Bible says. It's not about the science. It's about school. She doesn't want it in school. It's funny. So
Just because-
emotional.
Yeah. I mean, we've demonstrated what the science demonstrates, what the science shows, but we know who is the lower G, God of this world. We understand theology. We know what the Bible says. Okay. We know where this world is headed. Things are not getting better. Okay. So we're not expecting a sudden turning towards the truth of creation being taught in all schools, including, public schools. So
natural phenomena. But the heat problem is starting to change that. Now, like I said, I have done just oodles and oodles of videos on this subject, and I'm not inclined to sit down and record the same thing every single time.
See, the evolutionists won't admit it, but they require miracles in a worldview where they have presuppositions that only allow for what? Materialism and naturalism.
Right.
And yet they have no real explanation for the origin of life. They have no real good explanation for the origin of time, matter, and space. These are unanswered questions. Well, we're here. They have no answers to a lot of the genetic related evidence that we discussed. So they require miracles without having to admit it. So they have a science fiction religion, and their science fiction religion doesn't belong in schools. Okay. But the problem is they have a worldview and a starting point that doesn't allow for miracles and supernatural explanations. But our worldview, the correct worldview, okay, the creation worldview, Christianity, we just did 2 shows, one with Dr. Frank Turek and the other one with Detective J. Warner Wallace, demonstrating why Christianity is true. So we got plenty of evidence there that people can engage. So yeah, we can invoke the supernatural when necessary, of course, but the evolutionary model, they require miracles, but they're not allowed to have miracles.
As I've already done many times over, I've gotten sick of it. So this video is going to have a few clips where I feel appropriate. So first things first, what is the heat problem? You can find a seriously in-depth look at the heat problem here, and then also...
Okay, let's skip a bit because Matt, the first 20 minutes, you and I, we went over what she's going to go over here. We went into the rape project, all of that. So we discussed what the heat problem was. So I'm going to move around here to where she critiques us a little bit.
The Earth or in isolation in labs for specific elements, specific decay chains, what have you. That's not a problem for conventional science because it's only a little bit every year. 100 million years worth.
Okay, Matt, maybe you want to reiterate a couple points here. You talked about this at the beginning, the 500 millions of years of decay within a year. Okay, would be like 44 H-bombs per kilometer. Okay, so a lot of nuclear power there in just a year. So you described that. And what did we talk about for the first hour? Is this even necessary?
No, it's not necessary, but it was their only concept at the time to try to figure out how are we going to explain both old and young evidence inside of zircon crystals? How are we going to be able to explain why there's so much radiogenic lead as the daughter isotope if it decayed over a short amount of time? The only concept that they had at the time was accelerated nuclear decay. It was their only concept. So they said that it must have happened, but the heat was too much. Therefore, God must have removed it. It was the only idea that they had at the time. They could have sat around and thought more about it, but it's their model. They wanted to release it. I don't know how long they spent on it. They also have other concepts that they have to deal with as well. But there was only a handful of people working on this, right? This is like Walt Brown. He wrote the hydroplate theory by himself. You know how long that took him? His whole life.
One man show.
Yeah, his whole life dedicated to it. So,
and yet these guys got hundreds to thousands of researchers. They've got all the grant money. They've got the millions of dollars to study these issues. And one thing that I think those who would hold to accelerate. Now, I believe in multiple working hypotheses. That's why they'll say, I've seen it in the chats, and Erica says here, well, what does Donny hold to? He's bouncing back and forth between accelerated decay and no accelerated decay. No, me and Michael Ord and we talk about frequently in our shows together. We've done a whole lecture series together. The importance of multiple working hypotheses. Okay. Don't just rely solely on one hypothesis. And then if that fails, that's it. You're left with nothing. No, multiple working hypotheses have numerous hypotheses with valid explanations, maybe some not so valid. And so, yeah, you can go with accelerated decay because, again, there is some interesting evidence for it, like the helium. Okay. Or here's an alternative explanation. Here's a separate hypothesis. Okay. So you have different hypotheses to choose from to explain what we see from this worldview. Okay. And so it's not that accelerated decay is 100% untrue. It's that, hey, here's an alternative explanation that doesn't require accelerated decay, which means we can easier explain the heat and the radiation. Is that an accurate summary, brother?
Exactly. All we would need to do would be able to explain the amount of heat that would be generated to cause the distribution of the radioactive elements to distribute themselves differently based on density in a rock. And you only need a couple, tens of thousands of years of accelerated decay, not millions and like they're talking about. That's just way out the charts. We're talking thousands of years of accelerated decay. That's not much at all. So we can explain that in a year, but we can't explain 500 plus million years of decay in 1 year. That is true. You melt the earth 5 times over.
That's right. So we still have some I mean, in labs, they've sped up the decay rate of certain isotopes here by 1 billion times. Dr. Lyle talked about that in his last show with us. And so Andrew says, what about when each of those hypotheses have failed, though? But they haven't, because even your accelerated decay model, okay, working creation scientists like Dr. Humphreys, Dr. Baumgartner, they would challenge the evolutionary community to address what they've presented, like helium and zircon crystals and C14 and diamonds. Dr. Andrew Snelling, he just did a lecture on radio halos. Erica put out a response, but Dr. Snelling has pointed out that these criticisms and these objections fail, and he's provided technical rebuttals to those. And Dr. Andrew Snelling actually pointed out that if there was too much heat and radiation, we shouldn't actually find these radio halos because those scars in the rocks are obliterated at high temperatures. So the question is, have the evolutionary community adequately addressed these arguments? And then there's another hypothesis where, Matt, you've demonstrated that these proportions that we find in the geologic rock strata can be explained without accelerated decay. Now we have an easier explanation for heat. Okay, so let's keep going here.
Worth of decay. This is the equivalent of setting off 44 hydrogen bombs in every cubic kilometer of the planet. And if we up it to 4.5 billion years, it's 1.68 times 10 raised 30 joules. 402 hydrogen bombs for every cubic kilometer. For the record, to boil the oceans, you need 5.6 times 10 raised 20.
So I pointed out that during the flood, you'd have a mile or more worth of water, okay, that can shield Noah and the animals from radiation, right? We see this in nuclear reactors where they have water present, but their follow-up is, well, that can't be the case because then the radioactive isotopes in our bodies, like potassium, would accelerate as well and kill us, as in the water is not going to shield us from those elements. What's a good response, brother?
Well, remember, it depends on the flood model. Are you going with Walt Brown's hyperplate theory? Because remember, there was no radioactive elements that would have been in the human body or animal bodies to melt them. They just didn't exist yet because they were being formed in the flood. So again, it goes back to, what do you want to believe? What flood model do you follow? If you're just going to listen to her that the heat just destroys everything with catastrophic plate tectonics, then just don't believe the model. You don't have to. There's no reason you have to believe one. You and I believe in a hybrid version, a mix of multiple ones, because we're not confined to forcing our belief into one thing. We don't care where the evidence goes. We just follow it. And we're like, this is the best explanation that there is. So we have a hybrid model. So then how much, you speed up the radioactive decay 600 million years. Yeah, they're going to hurt Noah pretty bad. But you accelerate it by a few thousand, it's not bad, because it's over a year. So it comes down to the numbers, the number game. And if God is removing heat, like he said, how fast is he removing it? Apparently before it would ever harm any living life. So different types of answers for different types of scenarios, different models.
6 joules of energy, and to vaporize it completely, you need 3.7 times 10 raised 27 joules. So that's just the nuclear decay. You can add things like the lithification of limestone, the hardening of all of the magma that we have to explain in the geologic column, all of the impact events, and the friction of the continents as they go from Pangea to the current positioning or
Now, these things that she's talking about have an easier explanation in multiple working solutions when you don't have to account for radiation and heat from accelerated decay. That's where we could now, because I understand what they're saying, that if you have accelerated decay, right, Matt, then having all the massive amounts of plants, right? Because I pointed out the pre-flood world could have acted as the perfect battery to absorb portions of the heat generated from the Genesis flood. There is a powerful connection between the rapid formation of coal, oil, and heat. The pre-flood world was 95% habitable. There would have been billions of creatures, a lot of biodiversity. Okay, so the pre-flood world would have been largely green. We know plants can absorb heat and toxins. And so there's a lot of potential to absorb a great deal of that heat. Maybe it's a small percentage, but if you don't have the accelerated decay and you don't have all of that heat and radiation, the 500 million years worth in just a year's time, then this solution is a lot stronger. Okay. And so the supposed crude oil, coal, and gas, the fossil fuels that are said to have formed over millions of years from the remains of dead organisms, the flood has that in play, dead organisms, plants, massive amounts of plants, for that heat to be utilized to form coal, oil, and natural gas. Okay, now I get it. If accelerated decay is in play, then that's really not going to do much. Okay, it's only going to absorb a little bit of the heat, but you still got so much from accelerated nuclear decay. Okay, and this also goes for the hypercanes. Yeah, if accelerated decay is true, then that's just too much heat. That, okay, the hypercanes and then the coal, oil, and natural gas, it's only going to be a tiny portion. Okay, but remove the accelerated decay. Now we have some elegant solutions. Okay. So anyways, I just wanted to point that out. We'll continue here. Would you agree with that, Matt? If we don't have the heat and radiation from accelerated decay, now it's a lot easier to explain what she's describing here. Limestone, meteorites, friction of continents. Did you want to briefly address the meteorites, brother? What about all those meteor impacts during the flood? Isn't that alone producing too much heat for the earth to handle?
Again, yes, if you were going to assume that the earth was being bombarded by every single fossilized meteorite impact that we found, which is around 200, and they all occurred in a single year, yes, they have another heat problem. The only problem with that is they just don't need to invoke that because, again, a lot of those, what they assumed were meteor impacts, are actually underground volcanoes called Mars. And some of them are very big, like supposedly the volcano that killed the dinosaurs. I'm sorry, the meteor that killed them is actually an underground volcano. So once you get rid of some of these massive catastrophic meteor bombardments, you limit the amount of heat that was going on during the flood. So again, catastrophic plate tectonics created a lot of their own problems. I don't know necessarily why they did for all of them, but that one was because they needed to explain all those meteor impacts in the different geologic layers. And they said, well, they must have happened all within 1 year while those layers were actually forming. But we know actual layers can form after that as well. Like, for example, about 1,000 years after the flood, when there was an ice age melt off that also caused another flood to run over lots of northern Africa, creating this Sahara Desert and a lot of other regions, all North America. So there's just so many different aspects that I don't think they really considered when creating the model, and set themselves back for ridicule and arguments against them by doing that.
Great point. So they're overestimating the problem with the meteorite.
They created their own problem. Yeah.
So quickly, Doug Meeks, I just addressed this, but thank you for your comment. He says, LOL, you abandon accelerated decay to avoid the heat problem. Gutsick Gibbon is right in the subject of her title. No, I am showing you multiple working hypotheses where you can go with accelerated decay, because there is some good evidence for it, like the helium and zircon crystals being one of them, okay, and the lack of good rebuttal. I get it, Erica, she's put out a video, okay, but people who have studied this extensively, like Dr. Russell Humphreys, who made this amazing prediction, and it was confirmed, he has, in a sophisticated manner, responded to these criticisms. So you can go with accelerated decay, okay, which there's no good rebuttal to, but accelerated decay does result in a lot of heat, a lot of radiation that will require, most likely, a supernatural explanation. Okay, some people don't mind that. All right, we hold to a worldview and have presuppositions where miracles are allowed. Or here's a different explanation for the helium and zircon crystals from the Young Earth creation model, for example, and the proportions and ratios that we find these isotopes in, right, Matt? Here's another hypothesis you can hold to that doesn't require accelerated decay, and so does not necessitate a miracle. So there's multiple working hypotheses. You can choose your own. Isn't that right, Matt? We're just showing the possibilities.
Exactly. That's what me and you actually do. We come across new information, we share it with people because there's different answers, because that's what science does. No one scientist completely agree with one another. Even in the evolutionary community, there's dissent all over the place with different models. Same thing happens in the Young Earth community. You don't have to appeal to a single model and hold just to that. You can mix it up, make varieties. Matter of fact, share a screen real quick. Let me take you through a real quick journey about how the Earth was supposedly formed, which was through meteor bombardment over billions of years, and it was supposedly a hellish environment. But let's look inside the very books themselves of what the experts say. The lack of fossil record of true meteorites is actually puzzling. So if the Earth actually formed through meteor bombardment, why are they so hard to find? Why are they so rare? What was going on? Look, things were actually looking more like the modern world in some aspects early on. There was water, but what does the Bible say the Earth was in the beginning? Water, potentially some stable crust. It's not completely out of the question that there would have been a habitable world and life of some kind. And then a stoutly solid, temperate, meteor-clear, and watery world, and Eden from the very beginning. And then what do we find? Well, when granite is heated to a particular temperature, it converts to rhyolite and never converts back again. It can never become granite. So obviously there wasn't that much heat to melt all of the granite from the creation of the world, because we still have granite. And look at these mountains. How does granite bend like that? It doesn't, unless it was soft when it rose out of the flood very quickly and then solidified into the hard granite that we see now today with mountains. And that couldn't have been melted. It couldn't have been from an overly melted planet from accelerated nuclear decay. So therefore, there must have been something else going on. And I believe that the best answer is what we see at the Proton 21 laboratories, which shows that these elements are created as we see them, even though they date very, very old. And the best argument against that would be God is trying to trick us. You're muted, by the way.
There we go. I was saying great points. And yeah, I mean, we demonstrated earlier the fallacious nature of saying the Earth looks old or the universe looks old. And so we put out a video. We put out a lot of videos recently engaging topics that the critics, they need to address, many challenges to their position. And so, okay, let's continue here. And Matt, double check with me. Let me know that the video audio is still being shared.
Rodinia to separating out and then Pangea to current positioning. Like, none of this works. It's an obscene amount of.
Now, which is what I would believe, that a great portion of the water, I think this is where the HPT model goes right. Matt, I'd be curious as to your thoughts, because we have massive amounts of water, okay, reservoirs of water in deep subterranean vents. Water coming up into the ocean, which means it's got to be coming up from lower than that. And so a lot of the water for the flood came up when the fountains of the great deep broke open. Okay. Firstly, you'd have supersonic jets that could take a lot of this heat and radiation up into space. Heat can be taken into space. Okay. We have many different ways to move heat around. Convection, radiation, there's one to move it into space. Conduction. Okay, so it is possible. And the water would act as a lubricant. Yeah, if it's mostly magma coming up, that's going to be difficult. But if there's a lot of water, then those plates, there's going to be a lot of lubrication as they move around. Okay, so the friction is going to be a lot less than they would argue. Would you agree with that? With the water, a large part of the water coming from the fountains of the great deep, brother?
Yeah, creating the oceans that we see in the world today. And think about it, we all icebergs are fresh water. That's why they float. And a lot of the pre-flood ocean could have been less salinated, because when we look at the salinization rate on how fast equilibrium would actually reach, the oceans should have reached equilibrium a long time ago. They haven't. Another perfect example of young Earth. And one of your favorites, which I'm screen sharing right now, is the subduction of cold plates. So if there was a rapid movement of plates that subducted down during the flood, it would have brought with it the continental crust that was above, bringing it down to Earth's core. Well, that's exactly what happened. How long ago? Well, they're still cold. What do you have to say about that?
Right. Yeah. Obviously, there wasn't as much heat that they say to destroy the Earth if we have these massive slabs of cool rock down in the Earth, where if they were taken down there millions of years ago, they should have melted or at least warmed up to the surrounding material.
Exactly. So we have a lot of evidence that this happened rapidly, and it happened recently. Now, sure, there is a problem with the heat, but we can answer that now, which we've done. So I think that we've satisfactorily given multiple lines of evidence that show, like, okay, we know how it happened. We know why it happened, and they won't believe that, but we at least can show that different varieties of science, geology, paleontology, they all have different forms of evidence to show us that this actually happened as an event. They can just take it or leave it. Obviously, they don't like all these forms of evidence, but that's not, science doesn't care about your emotions. It just gives you the answers. And we have those answers. So that's what's really cool.
And again, there's so much about the Earth's core. You and I, we've been digging into this over the last few days. There's still so much that scientists don't know. They admit that they make a lot of inferences and guesses in terms of the core and the interior of the Earth. Why is it so hot? How hot is it? Even today, they admit, if you go read this, why is the Earth's core so hot? And then there's other secular publications where they admit that it's largely just a guess. They don't really know. There's ways that they can go about and kind of guess what it is, but even then it's not really solid. And so Erica says, oh, we know how hot it was millions of years ago or in the past. Wait a minute. They're admitting that they don't even really know how hot it is now, let alone in the unmeasurable past. Okay. So look at here. Big guess, 7,000 to 12,000 degrees. Okay. In the pre-flood world, we don't know how hot it was. Yeah, it probably was hot, but not as hot as today, 7,000 to 12,000 degrees. Okay. Take the heat and radiation that is supposedly too much and put it right into the interior of the Earth. Okay. Most of the heat and energy produced during the flood could now be in Earth's core. It's a lot hotter now. And a rebuttal that just say, oh no, we know how hot it was in the past. No, you don't. Even now is just a guess. Okay. So no, they don't. How do secular scientists know what the temperature of the core was millions to billions of years ago? They don't. Again, it's just guesses and inferences. So yes, there could have been a way or multiple ways that in the pre-flood world, the core was hot. The interior of the Earth was hot, but not nearly as hot as it is now. And a lot of that heat and energy and radiation was taken into the core. Very plausible. Okay. And if you don't have the accelerated decay heat and radiation to account for, then it's a lot easier, because then there's going to be a lot less heat that needs to be taken into the core. And same thing, do the calculations about the Earth. Okay, all of this giant fauna, all these plants, an Earth that's 95% green. Okay, I think it's Jordan who claims to have done those calculations, but there's a lot of assumptions in there. There's a lot of unknowables going into that. Take all the dead organisms too. Like, there's a lot of ways to absorb that heat and to transfer that heat. Okay, here we go, Matt.
heat. Most of those numbers come from Young Earth Creationists too, which is notable. In fact, Answers in Genesis just last year released their 4th article in a series on heat problems associated with the Genesis flood. Chronologically, this is just the latest in a long series of creationists, Young Earth Creationists, trying to solve this issue with radioactive decay, ancient dates, and the heat problem.
Now, Matt, correct me if I'm wrong. Most of these creationists that are going about trying to solve the heat problem, for the most part, not saying all, they're assuming largely accelerated decay.
Correct. They're trying to get rid of the heat that comes from accelerated decay. That's literally all they're trying to do, which is a nearly impossible task, right? So they have an uphill battle to climb. That's why
and the meteorites, which you say is an overestimate.
Exactly. Oh, meteorites. Exactly. It's just they catastrophic splay tectonic really did do a number on themselves while creating their model. But that's expected when you're really trying to create a model that encompasses so many different fields of science. And I mean, it's really, really hard, I would imagine. I would love to create a flood model. I actually was in the process, but Jason deleted that book. Thank you.
We did put out the new and improved flood model, right? And then years ago, we put out the flood video on the Young Earth Creation channel that got a couple million views. Not everything in that video do we currently hold to, but in general, it's a great video with some incredible evidence for the flood.
Yeah. I mean, hours of content, man. We did so much. And going back real quick about how you were talking about Earth's core, if you just real quick share the screen, this is a great one because they've been talking about how thorium and uranium are the powerhouse for the rotation of the Earth. What is at Earth's core giving it energy? And they actually found that there's actually very little down there. They didn't even know this whole time. They've just been guessing. The more we learn, the less we realize we know. It's just so ironic that they trust every new textbook paper that comes out. They believe what they were taught in school as a fact, but yet that book is in the garbage can today. Half of it's wrong. What I was raised with in school in my textbook is garbage today. It's so long ago, but yet it's a fact today. But in 10 years they won't even believe it anymore. It'll be a new fact that they believe, but yet we're wrong. I just love that. It's so ridiculous. It's so emotional.
And, here's a question out of curiosity. Do the other planets, like or even the moon's not a planet, but Mars, Jupiter, Saturn, do those planetary sized bodies in the solar system, do they have cores that are hot?
Well, remember, some people believe that the moon is hollow and it's just an empty satellite because when the astronomers landed on it, made a bell sound. They said it kind of might be hollow. It also rotates at about like the same kind of pace that Earth does. So it always is facing us. So they're not really sure. Again, there's so many mysteries. If we don't even know what our own planet's core is,
right?
We know
if we're guessing.
More guessing. Yeah. It's just mystery after mystery.
Good old Google. So it says no. Mars and many of the other planetary sized bodies in our solar system have cold cores. Another one, do all planets have molten core? The answer is no. Take Mercury, for example. In this comparison of Earth, Mercury's core is thought to have a liquid outer core and solid inner core. So I don't know, but then this one says, do any planets have cold cores? It says all planets have a hot interior. But then over here, it says the cores are cold. So I don't know. There's some research there because that's pretty interesting. Why does the Earth have such a hot core and hot interior, but apparently the other planets don't? Well, for one, I think the Bible's true when it says that the current location of hell is in the center of the Earth. Okay. But the center of the Earth is massive. Okay. So where it's hot, well, the entirety of the interior of the Earth could now be extra hot like we see today, because at the flood, a lot of that heat and energy was transferred there. Okay. And I think those calculations could be done. And again, without the accelerated decay, again, we've read article after article over the last couple of days where scientists and researchers are saying, we don't even really know the temperature today of the Earth's core. They're just making guesses. And so you're going to tell me that what it was millions to billions of years ago? Yeah, right. So, all right, we're at the 2+ hour mark. It's been wild. So let's do just a couple more minutes here. Having watched her video more than once, less than twice, I rewatched today the pertinent parts just to make sure we address the major questions and challenges. And as far as my notes go, we've basically addressed it all. But let's do a couple more minutes out of fairness.
It started with the rate team, radioisotopes in the age of the Earth back in the early 2000s, and it's still going on today. And the conclusions, as you've seen.
Matt, I'm just going to skip to the ratios portion because we've addressed so much and we've addressed the critics in the chat. And I know you got to get going. You're supposed to get going like 20 minutes ago. So I'm just going to find this one part so we can respond to, and then we'll wrap it up. Okay. So let's see here.
The astronomer Jason Lyle, the late and hateful radio host show
About a guy who took that perspective. He showed up as a guest on the Standing For Truth channel being interviewed by point decay rates must have been faster, and that 3, that fast decay creates a whole lot of heat. So what do? Well, some creationists propose that accelerated nuclear decay simply creates too much.
Okay, so right here, this is what we've been proposing as a current working hypothesis, that the origin of radioactivity was a deep rock phenomenon, and there is usefulness to that radioactivity. Warm the earth during the creation week, warm the earth during the pre-flood world, help with vegetation, energy, so on and so forth. Okay. And at the flood, when the fountains of the great deep break open, that radioactivity is brought to the surface, brought to the forefront where it's now harmful. Okay. So here's her major objection to this. But you've already given a bunch of visuals in terms of a response earlier, brother. So right now, just do like an elevator pitch response. Here we go.
Much heat, and so it must not have happened. And they propose alternative solutions, such as maybe God just made the rocks to look old. But that's problematic, right? Because that means the flood would have to shuffle all the rocks precisely atom by atom, just to make it look as though they follow the laws of superposition.
Okay, so basically the flood would have shuffled those rocks, okay, and shuffled those atoms, atom by atom, to give the appearance that the lower rocks are older, date older, than the rocks at the top. That follows this law of superposition. Okay, so basically the proportions of these atoms, Matt. So is that a falsification of what we've been putting forth in order to not necessarily have to invoke accelerated decay?
Right. No, because not all rocks, like limestone, for example, absorb radioactive elements. So what was going on with the radioactive elements as they were being distributed during the flood? How were they getting into the rocks? Were rocks still rocks, or were they broken up? Did they have to solidify? They had to get into them somehow. And what was the distribution of them at the time? And we talked about their atomic mass, their density, and why, of course, the most important part of all was that the heavier isotopes tend to yield older ages. And that was exactly what we would expect, and why uranium dates older than potassium, and why they're based on their density. So sure, there's a little bit of accelerated nuclear decay that goes into that, but it's very small and negligible. It doesn't take 600 million years, which is catastrophic plate tectonics model, which is a ridiculous amount of heat. So that was what we covered earlier with the images, and showed all the different rocks that yield those results with experiments that show the exact same thing over and over. So I don't know what else they would want besides the observable, testable, repeatable studies that go over that. And that's it. It's just we can find it in the rocks today, and then we explain from the studies that the lab experiments that show that even when they are made just days before, they can still date billions of years old.
Okay, let's do this. So firstly, Gutsick Gibbon, good to see you here. Good to have you. Now, we have been going for over 2 hours. We had our good friends, Creation Myths. We had Dr. Joel Duff. We've had Grayson. We've had Andrew Cumming. So we spent the first hour engaging the critics, engaging the chat comprehensively. And so now we've just been responding to your video. So I understand you're busy. We would have loved if you were here for the first hour. We don't want it to look like we're ignoring your comments as we start to wind down here. But what we'll do as we're engaging this last point is, Matt, let me put a few of her responses here. Okay. So feel free to respond to this, Matt. And okay, so Gutsick Gibbon says, Matt is breaking all physics again because radioisotopes don't shuffle like that or at all. So it sounds like she's saying this shuffling that you're talking about it doesn't happen. It can't happen. What's a good response?
Well, the laboratory experiments that show that the distribution is laid out that the way it is, I guess that broke physics then. Something happened that caused the distribution to be the way that they are. If you don't like the results from the study because they have to break physics, that's not my problem. The distribution shows that we can go over why they are like that. But again, it comes down to what we see. How that happened, we don't know. We didn't see a global flood happen. We just know that it occurred, and we can see that. It's not my fault that you don't like the distribution and that they refute the evolutionary timeline. We literally look at multiple varieties of rocks. Here they all are, named right for you, from the RAID team that found this a long time ago and then confirmed more recently. And that is exactly the same thing every time. So again, if it breaks physics, then that's just another example of a miracle. But it doesn't really break physics because we literally see that in the rocks. It's okay.
So those that, again, we've been putting forth, Eric, I'd recommend you watch from the beginning. We've been going for 2.5 hours. We went over multiple different hypotheses. So accelerated decay, that position, they would say, well, the deeper rocks date older than the rocks at the top. We have this proportion, okay, this ordering, you can say. It's kind of like the ordering of the fossil record, but just with these atoms here, or these isotopes. And so they would say, well, rocks earlier in the flood would experience more hits of accelerated decay than rocks that are laid down later in the flood. And so just naturally through accelerated decay, your older rocks are going to date older because they're happening during the flood in a year than the ones at the top. But you're saying that, Matt, that this same sorting or ordering can take place based on how we've, for one, observed the experiments with the Z-pinch, right?
Right. That's their formation. And then distribution would be based on the solidification of the rocks and how, if they are faster, when they solidify, then they're not going to have a massive different distribution ratio where there was a more dense type of uranium that got deeper so it could test older. But regardless, most of the type that were tested showed disconcordance. That wouldn't be true if evolution was true. The rock layers show exactly what we would expect to see based on density. The very thing that the evolutionists would say, global flood makes no sense because, you would get everything mixed up. No, you wouldn't. You would get the most dense deeper. It just makes sense. But in some cases, they are all on the same plateau. And the reason why is because that type of mineral solidified very quickly before distribution could occur.
Okay, so now she says the elements did not shuffle in any order. Since we're on this, we've discussed this for quite a while, in any order in Proton 21.
Of course, because the Proton 21 laboratory wasn't distributing anything in any type of an element. It was literally taking a plasma and shooting a piece of copper, and the plasma, the ejection that came off of it, formed the different isotopes all over the copper peptide that was left over. It wasn't in a type of a stone, and it wasn't thrown into water. It was literally just creating the elements. So, of course, it wasn't shuffling anything. There was no shuffling to be done. It was literally creating elements so that they could utilize them and test them. Some of them disappeared within seconds.
And the way those elements formed, like we said at the beginning, gives us an analog to how God would have created the original rocks with a variety of atoms, massive amounts of daughter elements already present that did not get there through these long age decay, right? Right.
Exactly. Like, think of volcanoes. Volcanoes would pull gold out of the ground, right? Because it's a very heavy, dense element, and it would pull gold. But we don't find gold around volcanoes. Very interesting. Why would that be the case? What about radioactive elements? Where are a lot of them coming from? Where did they come from? If they're not in Earth's core, what's going on? So there's a lot of mysteries still to be figured out. We just wanted to know what their ratios and proportions were so we could date the age of the Earth. And when they're formed in the same ratio. So
I
I
do.
don't know how they
I mean,
deal with that. But
I mean, your critics have to at least admit that that's pretty amazing that they're formed in those ratios.
exactly, they don't mention that. They don't like that at
Yeah.
all, do they? They never mention it. So that's one of them, and the other one deals with getting rid of accelerated nuclear decay. But since they need the heat problem, they'll never accept the
Right.
daughter isotopes are in such a rapid proportion that it can create all of that lead in a matter of months or years. Why would they want an answer? They don't want answers.
Okay, here's a fair point. Appreciate it, Erica. She says, well, to invoke proton 21 is to invoke stellar conditions in the middle of the flood. So the flood being a massive geologic event, and obviously an event that comprised a lot of physics and chemistry and everything. Okay. But so she says heat problem again. Okay, fair point. What's a good response, Matt?
Easy. It wasn't taking place during the flood. It never happened. That's why. It's very, very simple.
It's the original created rocks, like we've been saying, right?
Exactly.
Yeah,
During creation. Yeah. You don't need accelerated nuclear decay. We're helping the catastrophic plate tectonics answer it naturalistically. Essentially, they could say, okay, the Z pinch occurred in the very day one of creation. Did God do it? I don't know. Sure. Or it just happened on its own during that process of the formation of the earth. And then what happened? They date old. It's just the way that it is. Why? Because they're rapidly decaying.
See, right
could
here
say,
is
well-
kind of... Oh, go ahead, brother.
I would say, well, they would say like, well, God is cheating people. He's lying to them because when you date something and it dates old, well, not necessarily, because we have the laboratory experiment to show that he's not lying, because we can literally test it now. And they date old, even though they're brand new. So there's not much of a trick, is it, if we can replicate it in the laboratory?
So this is more of an assertion, but I'm curious how, pretend it's a debate. So Gutsick Gibbon makes this assertion. She says, because they aren't, you guys. So we're saying it's amazing how those isotopes are formed. Okay. But she's saying they're not. So are you misunderstanding the study, or what is she implying here?
How could it be? You can literally go watch them do the experiments and then sell their results. It's okay. You don't have to believe the results. That's just what they are. I mean, how many times do I have to screen share the actual laboratory experiments where you can see them? It's okay.
Which you did for a while at the beginning. So
yeah, it's okay.
And so she makes an argument that, if A, then B, okay, then you cannot explain the order. But no, if she's wrong with A, then B is also wrong. So, I mean, you've demonstrated sufficiently the case here. And so, okay, then she says, your choices are God does, and in the flood, and you have a heat problem, or God does, and at creation, and you have a dates problem. Or if what Erica was saying with her premise in A, okay, that what you're saying is false. No, if what you're saying is true, then yes, you do have an explanation for the order and the dates.
Right. And it solves the heat problem. It gets rid of the problem that they're having with the distribution. There's a lot to it, and like you said about the flood channels that John Mackay is doing with the flood, just show that the different layers are formed. All he needs to do is add radioactive elements to that. Now, does he want to be around that? Probably not. But it's something that he could do. You can probably buy most radioactive elements except for uranium, because they use it for bombs and explosives. Probably not the best idea. But you can buy a lot of radioactive elements, and he could add them to his flume experiments and then make the layers and then let them solidify. And that's it. Once they solidify, then you'll have your distribution. Why can't he do that? I don't know. He probably can. It's just much more dangerous because he has kids coming around his flume experiments. I doubt you can have radioactive elements flowing around, a bunch of kids putting their hands in there, but something that he should do. I'm just saying.
So Erica, yeah, we're gonna wrap it up here. So Erica says, so let's pretend this is a challenge. She says, show the paper then, Matt. And I'm not saying you have to do that right now. So if you did, are you confident that the paper would be demonstrating what you're saying or what Erica is saying?
Well, there's tons of papers. There isn't just one. They're all over. That's why I wrote the book.
It's all the papers derived from the experiments, right?
Right, exactly. There's tons of experiments they did over the years, and they've made some incredible discoveries. They made one heavy element that was so big that it just literally created tons of elements from it rapidly. Incredible.
Okay, well, listen, we're going to wrap it up here because we went 2.5 hours. We were only supposed to go 90 minutes. So, Matt, I appreciate you giving and offering your extra time here. I think it was comprehensive. We engaged the critics for a while. We engaged a lot of comments, and we got through the majority of Erica's point. So we've given people much to consider. We've given them multiple working hypotheses. One, that you can go with the accelerated decay. We've talked about helium and zircon crystals at great length, or a model that I think is powerful that does not require accelerated decay. And then as a result, we've given numerous solutions. The core in the interior of the earth, I think, gives us an excellent research project. So that's 2.5 hours on this topic. And we're going to wrap it up, brother. I appreciate the study you've put into this, because as you're studying this, I'm off studying ERVs and just the topic of genetics and ancestry in general, brother. So,
Yeah.
okay, we're going to call her quits here. Matt, appreciate you doing this, brother. So we've got a short version we did with Kent, that people who don't really want 2.5 hours to discuss this topic, go watch that. Or you got 2.5 hours here where we had the opportunity to engage many of our favorite critics, including Dan the Man with the Plan, Joel Duff, Grayson Hawk / Nicolas Cage, Gutsick Gibbon, and how could we forget our very lovely Andrew Cumming. And so with that, guys, Standing for Truth is out.
Real quick, one last thing.
Yeah.
One last thing. Share my screen real quick. For everybody,
Marvel after credit scene coming in.
I remember, for everybody, I wrote a book on this. You guys can find it. Here's the different chapters if you want it. And if you're a member, all you have to do is become either a member or a Patreon. Even if it's $1, it doesn't really matter. I would just giving it away. So I'll send the link to Donny, and anybody that's a member, just ask, or if you want it, it doesn't matter. He'll just send you a link just for subscribing. That was all. Okay.
I'll say this as the last thing, Erica. We do appreciate your comments and your video. This, I would just say, is an assertion, and that's fine. She says her questions were not engaged.
Okay,
I say her questions were engaged. So okay, I guess there's it's a tie. So leave it up to the audience. You know what? I'm going to put this out there to the audience, whether skeptics or non-skeptics. Go watch Erica's video. Be fair. Go watch her whole video. Watch our video. Come to your own conclusion. Be objective. That's what we do here with debates. Listen to both sides and then come to your conclusion. I'm not going to pretend that I understood everything that Matt said here. Okay. And so we got to do our due diligence and go look into this. But I can tell you, as someone who focuses a lot on endogenous retroviruses, chromosome 2 fusion, pseudogene, so on and so forth, when I engage the critics, like I am with Stated Clearly, like I have with Dr. Dan, they're not actually engaging the challenges that I'm putting forth. So when I hear somebody say, oh, you haven't engaged this question, or we've already answered that, I don't put a lot of confidence in that. Okay. So Matt, any final words, brother?
Yeah, no, I would just say we talked about it for over an hour or 2 hours. So it literally answered everything. It's just, I can't go over it anymore. I got to go to work.
Yeah.
Go.
Okay, brother.
Answering the same thing. I'm sorry.
All right, brother. Good work. Great work. We're going to chat later. We're going to get you out of here. See you, brother. Okay, there we go, guys. It's just you and me. I did want to let people know why we had the opportunity, because Matt and I, we've been working on this for a little while now, and he's been working on his side of things. I've been working on my own side of things on the heat problem, which I've presented in terms of the core and the work there. We had a debate planned earlier with Scott Clem and Sean Griffin, but one of the debaters was sick, so we had to reschedule, and we thought, okay, let's do this one tonight. Is Gutsick Gibbon right? Is the heat problem the death of creation? So we'll leave that up to you guys. Go watch her video, watch our video, watch the abridged version, and then you can also watch this video. Okay. And as I pointed out earlier, when it comes to the helium and zircon crystals, we spent a lot of time on that. Erica has given some responses to that. She's also given some responses to radio halos, but Dr. Andrew Snelling and also Dr. Russell Humphreys, they've given 2 technical lectures recently over the last few months where they've engaged the critics. Dr. Humphreys has pointed out that he's disappointed and with the criticisms that have come in, and those have been engaged. So you can find his responses on creation.com. Just type in Russell Humphreys, helium, and you'll see what he has to say on that. Okay, so you got some options there: accelerated decay or a model or two without accelerated decay. And that's why multiple working hypotheses, they're important. Okay, and so let's see. Erica says, Donnie, you actually never responded to my video on that topic. My points were not engaged by either Humphreys or Snelling. Well, I'll tell you what, I know Dr. Snelling engaged some of the points on radio halos because I personally sent in some questions and I derived those questions from your response. And so I can send you the timestamp if you'd like to, where Andrew Snelling responds to that. In terms of Dr. Humphreys, George Bond has had some quite a bit of communication back and forth through email with Dr. Humphreys on the heat problem and how long it would take to transfer a lot of that heat and radiation to the core. So that's something George has been working on. And so I can send those objections to Dr. Humphreys and get a response to him. Okay. So I do appreciate the engagement there. Also, thank you everybody for the support and super chat. Mitchell, I saw your super chat come in. And then Richie Taurus MMA. I would recommend, brother, if you go start at the beginning, we did discuss largely the presuppositions and the worldview aspect of this debate. Okay. And so our worldview, our presuppositions, we have no problem with miracles and the supernatural. Actually, the supernatural and miracles are necessary to explain what we see in the universe. Okay. If you have a worldview that lacks any kind of miracles, then you're not going to be able to explain a lot of what we see, a lot of reality. Okay. But we just enjoy engaging the critics and working towards a stronger model, giving, if we can, scientific explanations for that which may have a supernatural explanation. We're not ruling that out, okay? We're just being diligent, and we are doing our best to leave no stone unturned on these issues. But ultimately, it's going to come down to the Holy Spirit. It's going to come down to conviction, because that's why I said earlier that everybody, regardless of the worldview, they're going to have a rescue device. If they don't want to give up that worldview and those presuppositions and tap out and repent, well, every worldview, even ours, we're going to have rescue devices for things that may not at the moment have a ready explanation. Okay. And so those in the evolutionist camp, if they don't want to give up their presuppositions and worldview, then yeah, regardless of the challenge, no matter how big, no matter how small, they're going to make something up. But the question is that rescue device convincing? Is that rescue device feasible? What's the most parsimonious explanation for a lot of the data points and evidence that we have here? Okay. So Kathleen, I think I saw your comment earlier, sister, on a video I released today, I responded to the Kentucky atheist on the Y chromosome. And so you guys can see that. I think we've done 3 or 4 shows in the last 24 hours. And so I saw your comment. You're looking for the Eve data, the Eve consensus sequence. So I can send that to you for sure. I'll try and get it in a comment, or you can email me, standingfortruthministries@gmail.com, and I'll send it to you. Okay, let's see. I think we're going to kind of wrap it up here because I feel like I'm losing my voice. So for those who haven't seen the video earlier I put out, again, I respond to the Y chromosome issue from the Kentucky atheist, and Gutsick Gibbon, the superstar in the chat. I engage just a little bit your points on the Y chromosome, but I'll be putting on a detailed response to that video at some point in the future as I work through the newest papers on the issues. So, okay, guys, we're going to wrap up here. I hope everybody enjoyed. Again, just if you're invested in this issue on the heat problem, feel free. Watch Erica's video, watch this video. I'm confident that we were very comprehensive, and we were blessed in many ways to have a lot of our favorite critics here that we could take time to address their comments, their criticisms, their challenges, their objections. And that helps us to leave no stone unturned, which is why I do enjoy doing these live. Okay, guys. So appreciate you tuning in, and enjoy the rest of your Thursday. God bless. Standing for Truth is out.